Welcome to our course on Pyramid, a Python web application framework. In this section, we'll introduce the course, the content, what we hope you will learn, and all the secrets to help you get started quickly with Pyramid. Let's begin with Pyramid. Web application frameworks are the heart of dynamic web applications. Python has been a favorite language for web applications large and small for decades. Web application frameworks make it easier to write powerful, featureful web apps with Python. Pyramid is one of a handful of top Python web application frameworks, though there are many. Pyramid started in 2008 as repos.bfg. In November 2010, Pylons, one of the historically top Python web frameworks, merged into a new project based on BFG with the new name of Pyramid. This name has a special meaning. The BFG and Pylons teams agreed to the merger at the Luxor Hotel in Las Vegas, which looks like a big black pyramid. Pyramid has had over 200 releases over the years, with over 70 contributors. It was one of the first web frameworks to support Python 3. It's used now for many large and many interesting websites and applications. With so many Python web frameworks, what makes Pyramid unique? Pyramid is in the genre of micro frameworks, meaning a small core into which you add your particular choices for database, templating, etc. In that sense, Pyramid is non-opinionated about particular technologies, instead providing quality plugins. Where Pyramid excels, though, is in building larger-scale web applications. It provides, as we'll see, a unique and powerful architecture for composing and extending systems from smaller pieces produced by yourself, your team, or the community. In particular, Pyramid has a unique, built-in, but extensible architecture for authentication and authorization security policies based on access control lists. From its inception, Pyramid tried to be clear about what it wanted to achieve. Unlike other technologies at the time, Pyramid wanted to let you begin from a very small, simple starting point. As you needed more, it would reveal more. But equally, Pyramid didn't want to be a toy that you'd immediately outgrow. While you might start small, your project might be quite large when finished. And finally, software, like marriage, is a long-term commitment. Pyramid wanted to reflect the reality of maintenance to stay finished. The first solution for this is quality. The Pyramid codebase is written by people with a long history in this domain. In fact, some were doing Python web development in 1993. For Chris McDonough, Pyramid's creator, this is his third framework as a primary developer. This reflects itself not only in the architectural maturity, aka grown-up coding, but also in test coverage, which has been at 100% since initial publication. Also, the documentation has had full coverage from before the beginning, as the docs were released before the software. This is also reflected in performance. Due to the prior experience, the Pyramid team knew some of the classic traps. Pyramid has consistently outperformed the major Python web frameworks, largely due to less magic and fewer functions performed per request. For people developing with Pyramid, the overriding goal for them has always been only pay for what you eat. As mentioned, Pyramid is non-opinionated. In fact, Pyramid doesn't ship with a default templating system, instead making it trivial to install and plug in several mainstream choices. This applies further. Most of Pyramid's architecture is opt-in. This helps avoid the dreaded pain of most web developers, where they spend more time fighting the framework than working on their actual application. These goals and unique features have led Pyramid to be appreciated not just as a good starting point, but as a framework, software and architecture that let you make a built-for-purpose, reusable, custom, in-house or community framework. Course for Pyramid is aimed at the beginner to intermediate Python web developer. While we don't explain much about Python itself, you can still be successful in this course with a minimum of Python coding experience. This is true for web skills such as HTML, CSS, and JavaScript. At the same time, if you are an experienced Python web developer looking for an extensible web framework, this course provides a good overview of the Pyramid basics while finishing with some of the framework features. Pyramid's start small, finish big mantra is reflected in this course's outline. The game plan, cover a little, about a lot, a practical introduction to the most common facilities. We start, of course, at the beginning, installing Pyramid in Python. We then do a quick treatment of the basics, starting Pyramid and publishing a dynamic URL using views and templates. We then shift gears and cover Python's approach to developing in packages that can be put into production or redistributed, and how Pyramid taps deeply into this Pythonic approach to projects. With that in place, we look in more depth at views that match up to URLs using a routing system, followed by templating using the most popular Python templating engines. We finish that part of the course by plugging in static resources such as CSS. Publishing databases on the web is one of the most common tasks in web applications. We spend a full section on forms and databases, including sessions. Next, we get a little more advanced by covering in detail Pyramid's architecture for authenticating with logins and authorization of resources and views. We include extending this to database-driven applications. Finally, we go in depth on two intermediate topics. First, browser-based applications with REST and JSON are currently all the rage. We have a full series of sections on this topic, first with jQuery, then with AngularJS. Next, we go into Pyramid's extensibility story for building sites out of reusable, extensible plugins. Getting started in this course doesn't require much background. A basic introduction to Python should suffice. The examples use Python 3, but can be adapted to use Python 2. Also, we run commands from a command line, so you'll need some familiarity with command line tools. We're excited about bringing this practical Introduction to Pyramid course to you and hope you find it useful. Thank you for taking this course and diving into Pyramid. Pyramid is a web framework for Python. Let's start this video series by getting Python installed and set up. Python itself is available in two major flavors, Python 3 and Python 2. Pyramid supports both. This video series uses Python 3.4, but illustrates code which should work fine with no or few changes under Python 2.7. Let's begin. Where to get your Python? Linux users can easily install a package to get Python on their system. Windows users, though, need to install from python.org. OS X, which I use, ships with a Python 2.7 in the system, but staying with updates and newer versions requires an installation. You have many choices, including a binary installer from python.org, or package systems such as Homebrew, which I use. After installation, I have Python 3.4 available in my terminal thanks to Homebrew. Writing Python programs means working on multiple projects. Each project will require different Python packages as part of development. You don't want each project's extra packages to trample on the development of others. You need isolation. Python provides this through virtual environments, which are now a standard part of Python 3.4. Onto the code. Let's make a directory to hold each segment in the video series as a project area. We want this Python project to be isolated from other Python projects, which means a virtual environment for Python. I like to place my virtual environments inside my project with a name which indicates the version of Python being used in case I want to test my project under multiple virtual Pythons. This command invokes Python with the venv module, telling it to make a virtual environment inside the current directory with a name of env34. As a note, I could have also invoked this on Linux and OS X by a dedicated pyvim command. Some versions of Python 3.4 on Windows have trouble making the script available, which is why we're not using it in this video series. Next, let's see what this produced in our virtual env. We have an isolated Python command. We also have an isolated pip command. Pip is the system for installing new Python packages. The pip in this virtual environment will install new packages in isolation only for this project. How can we make sure we use this virtual Python in pip? We can activate this virtual environment for this console session. As you can see, our environment is now using the Python and pip from this virtual environment. It also changed the prompt to remind us of this fact. Each time you open a console session, you will need to either activate the virtual environment or remember to use full paths when invoking the Python or pip command. On Windows, the activation process is slightly different. For example, you might need to type something that looks like this. Running this on Windows executes a windows.bat batch file, which activates your virtual environment. In this segment, we installed Python, set up a project area for our Pyramid tutorial, and learned about Python development with virtual environments for isolation. We are now ready for Pyramid. Installing Pyramid into your virtual environment is very easy. In this segment, we use Python's pip command to install the Pyramid package. Let's first review our previous step. We installed Python, made a project directory for this video series, and set up a virtual environment to isolate development for this project. We also learned that you can activate this virtual environment in the console shell. As a reminder, activation looks like this. In future lessons, please ensure your console prompt, as shown here, indicates that you are in the activated virtual environment. Let's use pip, Python's package installer, to get Pyramid and its dependencies into this virtual environment. After Pyramid installs itself and its dependencies, it installs some commands into your virtual environment. Let's confirm that these are present. We can see our virtual environment has new commands such as pserve. This segment was brief. We simply used Python's pip command to install the Pyramid package into our virtual environment. Let's move on to a tiny working Pyramid app. We have now set up Python and Pyramid. In this segment, we will make and run a very small Pyramid web app. As a note, I use PyCharm, an integrated development environment, when doing my Python development. This video series shows PyCharm in the demonstrations. While PyCharm or another IDE can boost productivity, it is not a requirement. First, as usual, please ensure you are in the project directory and have activated your virtual environment. I'm using a console in PyCharm, and I have the env34 in my prompt to show that I've activated my virtual environment. Your Pyramid project can start very small, in fact, in a single Python file. If you save this file to a file named app.py in your project directory, you can then run this Pyramid web app directly with Python. This will start a Python-based web server on your local machine, listening on port 6543. This is the URL that you will visit in a browser. Open that URL, and you will see the output. This is the response from the Pyramid app. Let's analyze the code in app.py. We have three major sections: our imports, a Pyramid view, and the module run section. In the imports, we bring in a Python-based web server from the Python standard library. Python web apps are written to use Python's standard WSGI or WSGI interface. With this, any WSGI app, such as our Hello World here, can be hosted in any WSGI compliant server. Our view is very simple. The function is passed a Pyramid request, which provides access to incoming information in the HTTP request. This example uses nothing from the request. Instead, we return Pyramid's basic response object with a string that we see in the browser. The module run block uses a standard Python technique for self-running modules. The code inside this if runs only if this file is directly executed by Python on the command line, rather than importing this file for use in another app. The first line in the if block creates an instance of Pyramid's configurator. Unlike most Python web frameworks, Pyramid has an explicit and powerful configuration system. This removes magic and allows apps that can be configured by users without forking code. In this case, our configuration is done in Python. Later, we will do our wiring in a configuration file. Next, we add a route to map a URL to a view. The following line registers a view with the configuration system for that route. Finally, we make our WSGI app, register it with a server listening on a port, and wait for incoming requests. This segment was a very small first step into our first Pyramid web app. The next segments will introduce more Pyramid facilities while staying with a simple single-file Hello World demonstration. Our previous segment gave us a very basic Pyramid app. In this segment, we use Python Decorators to more conveniently configure our Pyramid views. First, let's review how we did so in our previous step. We had a function hello. At startup time, our app told the configurator to add that function as a new view associated with a route. To learn more about the configurator, let's see what happens if we reverse these two lines and add the route after adding the view. When I run this, it runs fine. The configurator groups up a bunch of work and then does the configuration. However, if we connect the view to an undefined route, then the configurator tells us no route named goodbye world found for view registration. Let's use the configurator to make view registration more convenient with Python decorators. In Python, decorators are a way to wrap a block of code with some extra processing. In our case, to take a function and register it as a view. In this new version of app.py, we import a viewConfig decorator from Pyramid. We then decorate our function, thus configuring it as a view, hence the name viewConfig. Finally, in our startup block, we remove the config.addView call to register each view. Instead, we tell the configurator to find and process any Pyramid configuration decorators in this package. Thus, we let the configuration statement as a decorator be very close to the view function. We can run this again directly from Python. Reloading in our browser gives the same results. In this segment, we learned more about the Pyramid configuration system, including how to use a Pyramid decorator to configure our view functions. Decorators give us a more natural way to register views, but rendering HTML directly from a function, most web developers use templates to generate HTML from data. In this segment, we will use Jinja 2, a very popular Python templating system with great Pyramid integration, to simplify our views by moving the HTML to a template file. As a note, Pyramid is a very unopinionated framework. It doesn't dictate your database, your templating engine, etc. In fact, Pyramid doesn't directly ship with a templating system of any kind. Instead, there are several high-quality Pyramid add-ons that integrate popular Python templating engines. Our first step, thus, is to install the Pyramid under Jinja 2 package, which gives us both Jinja 2 and the Pyramid integration to register it as a Pyramid renderer. Now that the software is installed, let's add it to our Pyramid app. In our configuration block, we include configuration commands from the Pyramid under Jinja 2 package. That package is then responsible for registering a new Pyramid renderer for Jinja 2. Among other things, this statement tells Pyramid that any template files ending in .jinja2 should be evaluated using Jinja 2. Next, we change our view config to add an extra configuration statement. This tells the configurator that this view should use a renderer of hello.jinja2. That is a Jinja 2 template file in the same directory. Thanks to this, our view only needs to return a dictionary of data rather than the HTML response from previous segments. Pyramid takes this return value of the view function, passes it into the Jinja 2 template, and returns the rendered result. Our template itself is very simple. In this template, the value of name from our view function result is inserted into the HTML response. Let's see this in action. In this case, the word world is in bold because our template surrounded the value of name from the view function in an HTML strong tag. To review, Pyramid configured a view for a route at a certain URL. When that URL was requested, Pyramid executed the view function and rendered the result using a Jinja 2 template. We have a simple Pyramid app with one route connected to one view. In this segment, we expand our app, showing how multiple URLs can combine with routes, views, and templates. Let's start by viewing the app in the browser. The root URL at / gives some introductory text with some links to other URLs. We can visit these other URLs and use the back button to return to this page. Now let's look at the implementation of this. Our site has two basic URLs, / and /hello. The latter can be requested with or without the request parameters we saw after the question mark in the URL. As such, we have two routes providing route names for the two URL bases. However, we have three views. How is it that we have two routes and three views? Let's look at the first one. This view with the function home is configured as a view for the route name homepage. When this view is called, it returns a dictionary and is rendered using the home.jinja2 template. Let's look at that template. This template inserts the site name from the view and links to the other URLs. The first link goes to just/hello. Our second view, Hello World, is configured to use the hello route. This Hello World view returns an empty result as our template doesn't insert any data. This is the hello world.jinja2 template used for that view, and there are no variables inserted in this. Finally, our third view uses the hello name function. This is called when the URL has $name at the end of it. Why is that? Looking at the view config, we see an extra piece of information, request under param equal name. This statement says to use this view when the request data has a parameter of name. Even though it shares the same route name, hello, as the second view, Pyramid chooses this view as it is more specific. This view gets the URL value of name from the request.params dictionary. This is the first time we use information in the request. In this case, we access params, a dictionary which includes, for HTTP GET requests, the values in the URL after the question mark. In this segment, we looked in more depth at the configuration system, URLs, routes, and views of Pyramid. We also introduced one of Pyramid's many view predicates, which allow us to make small views which match a URL in certain cases. This feature from Pyramid begins to show how Pyramid scales to larger apps with a very configurable URL space, an extensible system, less magic, smaller, and more focused views. We have now covered the most basic Pyramid facilities, such as routes, views, and templates. We used a Hello World style web app implemented as a single file Python application. This approach is useful when learning Pyramid, but Python developers write their Python code in a more solid fashion. That is, they develop in Python projects, which they distribute, for example, to a production server, as Python packages. A Python project is a directory with some extra information which organizes the files in that directory and subdirectories in a consistent way. This lets you write modular code that can be easily distributed within and outside of your team. Let's see how Python itself explains this by looking at the packaging.python.org website. We can see the definition of a project. Next, we click on the link for configuring your project. This explains the most important part of this section, the project's setup.py file. This is the project specification file. The Working in Development Mode section explains how, during development, we make use of packaging without actually creating and installing distribution packages. To begin on Python packaging, in this section we change our code into a Python package. We also use this as the moment to switch from Hello World to My Site, a fictional web app which we will develop during the remainder of this course. My Site will start with a home page and a to-do list. Let's take a brief tour of the work we will do in this section, then come back and look at the code in depth. First, our directory structure is richer. We have a directory for our Python project. This directory contains setup.py to manage our package, and a Pyramid configuration file, development.ini or ini. We also have a subdirectory MySite, which contains the actual code for our MySite project. By convention, Python developers name this directory the same as the package name. This directory contains a file init_.py, which Python uses to make this directory into a package. You must have this file, even if it is empty, to make the MySite directory importable. You can also, as we'll do, put code in the file that can be imported at the package level. Finally, we have a single template file in MySite. To execute the code in this Python project, we first have to install this project in what is called development mode or editable mode. Let's first make sure we are in our virtual environment. Looking at my prompt, I can see it does not mention the environment, so I will source it. Now I have in the prompt an indication that I'm in the virtual environment. Let's make sure and see if the pip command that is found in the path is the one in this virtual environment. And it is. Back to pip. I do my pip install command that we saw previously, but in this case, I add -e dot to install this project in editable mode. This pip command, as explained on the Python packaging page we saw above, downloads any dependencies in the setup.py file and makes a fake package linked to the directory with your in-development code. You can see this for yourself as we now have a new directory, mysite.egg-info. This directory contains some of the information that would have gone into a distribution package if we were not in editable mode. To run this Pyramid project, instead of using Python directly, we can now use Pyramid's pserve command against our Pyramid configuration file. pserve is a Python-based way to read a configuration file which wires up your Pyramid project. We will see more later with pserve. We can now view the results in a browser. pserve told us the URL to use. Back in my browser, I can make a request and get the response for this Pyramid web app. Let's go back and look at the code to see how this project works. First, let's look at setup.py. This is the project specification file. In this example, we make very little use of setup.py's functionality. We simply define what other software packages our project depends on, name the project, and define what is known in Python packaging as an entry point. Entry points are a place for this package to advertise plugin points for other packages. In this case, this entry point defines the location of the function to be used to get a WSGI application. In our case, it is the main function in the MySite package. As a reminder, WSGI stands for Web Services Gateway Interface and is a Python standard for letting your web app run in any of the many WSGI WSGI servers. As a note, anytime setup.py changes, you need to rerun pip install -e dot to regenerate the editable mode environment. Let's take a quick look at the documentation for entry points. In the Setup Tools documentation, there is a section Dynamic Discovery of Services and Plugins, which describes this concept of entry points, what it is used for, and how to use it. Next, let's look at the Pyramid configuration file used by pserve. Pyramid, as we'll see, has a robust configuration system. Configuration can be done in Python or in a .ini settings file, or both. In this file, we set a few things for running our web app in development. The app main section configures our WSGI application. The use setting tells Pyramid which entry point to use as the WSGI application. The server main section chooses which WSGI server to use, then configures the serving information such as the port. Not only does this move some code out of our project, importing the WSGI server and starting it up, we actually can run our project with different development and production servers without changing code. Finally, let's look at our Python code. Our entry point tells us the WSGI app starts with the main function in the MySite package. The MySite package, it's under init, and here is the main function. This file changed quite a bit as compared to our previous single file application. There is no block at the end with an if for running directly from Python. Also, we don't import and run a WSGI server such as WSGIref. Instead, our WSGI application is focused on the application, not the serving of the application. In this segment, we introduced Python packaging, which is a large and complex topic, but essential to modern Python development. We used the minimum from packaging. We also switched to use Pyramid's pserve to run our web app via a configuration file. Making the move to a Python package is a big step towards a mature project. With that in place, let's structure our project to better match a number of Pyramid practices. In this section, we will move our views into a separate file, make a directory for templates, and change our development configuration to use a better WSGI server. Along the way, we'll learn more about pip. Let's start with the WSGI server. WSGI, the Web Services Gateway Interface, is the Python standard for letting you choose which WSGI server to use with a WSGI application. We currently use WSGIref, a low-end reference library that ships with Python. Let's switch to Waitress, a production-capable pure Python WSGI server. We need to make Waitress a project dependency and then install the Waitress package. However, Waitress isn't required for the WSGI app, as we have proven so far by using WSGIref. Let's instead put this requirement in pip's requirements.txt file. This lets us state other software that gets installed to make a full environment, as explained on the Python packaging site. To install our project in development mode and also install requirements specified in requirements.txt for the environment, we add a -r dot to our pip install command. This pip command downloads and installs Waitress into our virtual environment. Using Waitress is now quite easy, a simple change to our development.ini configuration file. The value for use in the server main block now points to egg:\waitress #main. This means get the main entry point from the Waitress package. This shows again how Python's entry points in Python packages can advertise services. We also, in the app main block, add a setting to reload templates. By setting this, changes to our Jinja 2 template will be shown in the next page load without needing to restart our web app. This speeds up development. For performance reasons, though, you only want to do this in development. Hence, we put this setting in a development.ini configuration file. Later, we might create a production.ini file with different configuration settings, which we can use without changing our actual code. Finally, let's look in the My Site directory and look at the views.py file and see that there is a templates directory. The views.py contains the view code, where the only change is the addition of the subdirectory templates, where we are putting our Jinja 2 template files. With the view code moved out into its own views.py file, the packages _init_.py becomes concise and focused on bootstrapping the application. As a final point, note that we can start Pyramid's pserve with an option to automatically reload all the Python code whenever a file on disk with Python code changes. By passing --reload, we activate this functionality. So for example, if I changed this and saved, the application would restart. In this section, we reorganize the code in our Python project to be more modular while showing more of Pyramid's configuration power by switching WSGI servers. With this in place, we can expand into views and routes. With our My Site package properly structured, it is time to start working on the main views of the site. In this section, we look more at routes and the parameters which let you encode information into the URL, then use that information in your view. Along the way, we will make placeholder views for our to-do app. Let's start by viewing the results of this section in a browser. I have a view for the main listing of the site. This list view presents the items currently in the site. I can click on Add to see the /add URL, which goes to the Add view. Using my browser's back button, I go back to the listing view. I can view one of the items at /1 for the URL going to the view view. I can edit that by going to the /1/edit URL, which leads me to the edit view. And then finally, I can click on delete, which does nothing more than send me back to the list view. Back to the code on this. Our setup.py is unchanged, as is our development.ini configuration file. Thus, we will start by looking at our _init_.py file, which bootstraps our Pyramid web app. In this section, we have 5 routes defined for our to-do app. List the to-do items, add a to-do item, view a to-do item, edit a to-do item, and delete a to-do item. The URLs, for now, are off the URL root of /. Note the last 3 routes. They contain a curly braces ID curly braces. This is known as a route parameter. a special pattern in the URL which is extracted and made available at a variable name. In the case of view, if a URL of /27 is requested, the string value of 27 is extracted and made available in a special pyramid dictionary under the key of ID, because we asked for ID as the name of the route parameter. Thus, route parameters are the basis for matching URLs to data. The pyramid docs discuss router patterns and match dicts in depth. We can look at route matching and see the discussion and explanation. We can look at match dict and see some examples, for example, something very similar to what we just saw, and the docs also show how you can access this in your view code. Let's now look in views.py at how these routes are used. We have 5 views as indicated by the @view_config decorator. Here's a view, etc. These cover each of the 5 to-do operations: list, add, view, edit, and delete. The first 4 have templates associated with them. Let's look first at list.jinja2. This template is a full HTML file. The link to the add screen uses Jinja2 to insert a value from a Python expression. Inside the double curly braces, we see a Python expression. In this case, the Python expression is a call to Pyramid's request.route_URL API to compute the URL for the add route. We could have put the string in for the URL of the route, but if we later reorganized our URL space, we'd have to remember all the locations the URL was used. We then have an HTML table for each to-do item, currently hardwired to show just one fake entry. This entry has a link to the view, edit, and delete routes for this to-do item. Again, we use request.route_URL, but this time we pass in extra information. That is a value for the ID route parameter. Remember our route definition? Using the request.route_URL for this route means we have to provide a value for this parameter in order for the API to work. And that's why we're passing in an ID. Back to our views. Our view for viewing a to-do needs to know which to-do we want to view. That is, it wants the ID of the to-do, which we encode in the route parameter. How do we access that route parameter from a view? Using Pyramid's request.matchDict, which provides a dictionary for all of the matching route parameters. Note that we use Python's .get syntax on dictionaries to avoid a Python key error if we ask for a parameter that isn't in the dictionary. We then pass the value to the template by returning it in the dictionary. Let's open the template for this view to see this parameter in action. Displaying the value of the to-do ID in the template is done with a simple Jinja2 template variable insertion. Inside the curly braces for Jinja, we have a variable current that is available in the namespace of this template because we passed it in. Finally, our delete view does something special. Later, it will perform a delete operation in the database and then redirect the browser to the listing view. For now, we will just do the redirect. We do this by returning an HTTP found, a special pyramid object. This was imported at the top. Pyramid also lets you accomplish this redirection by raising a pyramid exception. As one final point, we define the routes in one place, under, init, under, and match those routes to views in another place, views.py. Why not place the route definitions close to the view definitions, or even better, conflate the definitions into one statement like other frameworks? 2 reasons. First, the order that the patterns are registered matters. In large code bases, you don't control the order that Python modules are imported, and thus don't control the order the routes are registered. Other systems try to get around this with some implicitness. Pyramid prefers less magic. Additionally, Pyramid tries to make the code distinct from the wiring of the code into a site, thus allowing consumers of code, customers of a website, to make their own URL space. In this section, we saw the start of our My Site to-do list. Even though we have stubs for the views, we introduced the important concepts of route parameters and using Pyramid to generate URLs. Our My Site web app now has some views for its to-do list. These views are all related. In this section, let's show the use of a view class in Pyramid to group the views. What is a view class? The Pyramid docs shown here illustrate what we have done to date. That is, each view has been a standalone function. Pyramid can also, though, let you use a class for your view. An instance of your view class is then available as the variable view inside your templates, allowing you to call helpers to do extra processing. Most people, though, have one class with multiple related views as different methods on the class. Let's take a look at how we've refactored our views from functions into a view class. We now have a class MySite. This class has a number of methods which are decorated with view config decorators, turning them into views registered with a route. Previously, when a request came in which matched a route, Pyramid would directly invoke the matching view function. With view classes, it is instead a two-step process. Pyramid finds the matching view and makes an instance of that view's class. Pyramid then invokes the method that matched for that view. The instance of that view class is then available in the template, as we can see in template/view.jinja2. In this template, we see the insertion of view.current to get the current to-do item. This is dynamically computed. Let's look back at the view class to find it. This helper method extracts some information from the request and makes it available as an attribute on the view instance in the template. Because we made it a Python et property, we don't have to call it with parenthesis in the template. We can just refer to it as an attribute. What do we gain from working this way with view classes instead of separate view functions? First, it's a matter of taste. Such grouping can be done in other ways. For example, by putting related views in their own module instead of a common class. You might, though, find that the views are coupled in some ways. They might share some looked up state, computation, or require some common initializing. View classes are a logical approach in these cases. Finally, you might find yourself repeating view config predicates, such as security statements, across lots of views. Pyramid has a way to decorate the view class as a whole with a view defaults decorator. In the Pyramid docs, we can see the explanation of this and the usage of this. In this segment, we converted our views to a view class with a helper property to use in templates. This video series will use view classes more than standalone view functions. For the most part, this is a style choice. Pyramid's system of predicates which narrow the matching of a request to a view is a powerful and unique feature. In this segment, we put that to use by showing how one route can map to one of many views based on information in the request. For example, many sites have a concept called self-posting forms. That is, a URL which, when requested with an HTTP GET, returns the form. But when the form is sent via an HTTP post to the same URL, the data are processed. Same URL, but the only difference is the HTTP verb used. Let's take a look at how we do this in Pyramid. The routes registered in our under and init under are unchanged. That is, the same URLs match to the same defined routes. We're going to be focusing in this segment on the edit route. Let's look at how our views match to that route. We now have two views, edit and edit under handler, which share the same route name of edit. How does Pyramid know which view to use? The second view, edit under handler, has an extra view predicate. That is, an extra criteria that must be true for that view to match. There's the criteria of route name, there's the criteria of renderer, and then this third view predicate, request under method, says that this request will only match when it was issued by an HTTP post. That is, a form submission. Let's show this in action. First, we start the server. The server is running on port 6543, and when we post a form in this console down here, we're going to have a print statement. In my browser, I go to my site, and I'm going to do an edit, and I'm going to say 22, submit, and we printed a new title of 22. Let's go back to our views and see how this was processed. Again, the second view, edit under handler, had a view predicate which made it more specific. When we first clicked the edit link, the browser issued an HTTP GET. Pyramid looked at each view, starting with the most specific view config, the second one. It's more specific because it has 3 view predicates instead of 2. This view didn't match the first request because clicking on the link is just an HTTP GET. The request method was a GET. It didn't match this criteria. So Pyramid kept looking, ultimately finding this other view. Same route name, but no restriction for request under method equals post. As you write Pyramid views, remember that Pyramid always tries the most specific view configuration first. Since the first view, edit, didn't have a predicate for request method, it matched. In fact, none of these others have a view predicate matching for request method. Why do they work? If omitted, Pyramid matches on any value for that predicate. Let's confirm by looking at the docs. Pyramid's view configuration docs. I see the predicate for request method. We have an explanation, and then the answer to this question. If you do not supply a request method, the view will match on any request no matter the value of request method. We could, though, make this more specific. Let's change our first edit view to say it will only match if the request method is a GET. Everything will still work okay in our browser. From the top, I'll click Reload, and I'll click Edit, and I still get the edit form. Let's make it not work by changing the request method to put. I'll go back, reload my browser. When I click on Edit, Pyramid could not find a matching view. Why? Clicking Edit sends a GET, and this only matches on put. There are no views configured for this route name that match on a GET. This pattern is very useful. You commonly see this self-posting form done more laboriously. Instead of having a separate method which matches on post, they do the test for post inside the same method. For example, get, or in fact, I'll just go ahead and remove this. And they will test self.request method equals post. And then all of this work would be done inside that conditional. Doing it this way in Pyramid with 2 separate views with the post matching on a predicate is a very powerful concept. Not only does it make your views more focused and easier to read, it also helps later when we write tests. And it isn't just for HTTP methods. You can also match a view based on the incoming data using a predicate. For example, let's have a view that is only matched when you click on a certain button. We start by changing our form to add a name attribute on the button with another button added to the form for canceling. We will change this to have form.submit. We will add another button for form.cancel, and we will put a value equal cancel to display in the HTML. Now we will change our view to add another parameter, another view predicate that says only match if you clicked on a certain button. And then Pyramid, that's request under param, and we will say form.submit. I now go to my edit form, and I see 2 buttons. If I say 22 and submit, this works correctly. I see this in the console. If I say 22 and cancel, then I do not see another print statement. Instead, I go to the edit view. I can trigger a not found to make the error more visible by changing this to a get. Click on edit, say 22. It could not find a matching view. Why is that? We had a request method of post, but this view said you had to click on the cancel button due to this view predicate. This view didn't match because it was a request method of post. Again, views with predicates is a very useful and powerful concept in Pyramid. What other predicates are available? The Pyramid docs show us route name, which we've seen, the type of request, parameters, whether this was submitted through AJAX, a number of other points, and you can even add custom predicates, which you define unique to your project to match on certain business criteria. In this section, we looked more into view predicates, lookup order, and showed useful web development problems they solve. Our MySite web app now has a number of views to cover various operations on a to-do list. Pyramid's configuration system, as we have seen, is very useful and flexible. Let's take a look at using it to customize how errors are displayed when you request a to-do ID that doesn't exist. First, let's show it in action. But this time, let's start from the top with the full sequence of setup, getting into the virtual environment, using pip to get our project into editable mode, and running pserve to start our web app. In the terminal, I can tell I'm not in my virtual environment because my prompt doesn't indicate that. So if I say source to activate it, my prompt now changes to show me which virtual environment I'm currently in. I can confirm this by checking which pip is being used, and it's the one in my virtual environment. Let's use pip to install this project into editable mode using requirements from the requirements.txt file. Finally, let's run pserve on our development configuration file and pass it the reload argument to make it restart when our code changes. Visiting this site in a browser gives us the same site from the previous section. If I hit reload, I see everything the way that it was. I can go to the first to-do and see /1 on the URL. I can click edit and see /1/edit on the URL. Let's edit that URL and go to a different to-do item, for example, 2. We see a custom not found error message showing the to-do item's ID. Let's take a look at how we did this in the code. Our only Python changes are in views.py. At the top, we import another decorator from Pyramid, in this case, the not found under view under config decorator. As you can see, it's a lot like the view under config, just with not found under in front of it. Our view class then gets a new method, not found, decorated with the not found under view under config decorator, the one that we imported at the top. This special view is given a Jinja2 template to use when rendering this view. Let's take a look at that template. The template is similar to the view.jinja2 template that we used previously. It has some explanation and gets a value from the view class, view.current, to show the to-do item ID that you tried to request and failed. What triggers the not found? Our view operation has a stub to simulate failing to get an item from a database. Here is this view, and it looks to see if the current to-do ID is a 1. If not, then raise this special exception. This is an exception that we imported from pyramid.http exceptions, and then used Python's exception handling to raise that custom exception if you did not get a known to-do ID. Previously, we showed doing a redirect by returning a pyramid object, but showed a similar technique. We used a return value of HTTP found as the response to a request. This shows a similar technique, giving back a special HTTP response by means of a pyramid-based Python exception instead of a return value. This example, raising instead of returning, is helpful in cases where you are several levels into a program. The pyramid documentation explains these special views, changing the not found view. The docs explain that when Pyramid receives a GET that raises this pyramid not found exception, or returns a pyramid not found response, execute this view that you have registered with the not found under view under config decorator. Before finishing this section, let's take a brief interlude to show how an IDE like PyCharm Professional Edition, shown here, can help. This IDE has special support for Python-based web frameworks, including Pyramid. As a brief example, we can ask PyCharm to run pserve for us in a special window. In the Run menu, under Edit Configurations, I have a pserve run configuration named pserve, and I have set it to single instance only. I have pointed it to my development.ini config file. I'm giving it extra options when running. And I finally told it, when you execute this run configuration, be nice to me and conveniently open a web browser at this URL. To run this, first I stop my existing server, since they will be on the same port. and I click this friendly green button. And there we go. I'm running it again in a special pserv window. Let's put an error in our code. For example, in the list view, let's just say X. When I save, it restarts automatically. When I reload my browser and see that there's an error, I get a much nicer error message formatted in a way that makes it very easy for me to jump to my error. For example, I will close these files and I will click on the link for the error that caused the problem, and PyCharm will open that file on the line that contained the error. Let's stop the run process and show PyCharm's debugging support, which is well integrated in Pyramid. I'm going to put a breakpoint with the red sign on this line in the helper current that we use to get the ID currently requested for the to-do item. If I click instead on the little green bug button, I will run this run configuration in debug mode instead of run mode, reloads the browser, and if I click on first, then I will go into PyCharm's debugger, showing me what frame I'm on, all the current environment data, and even letting me execute some arbitrary Python at this frame in the code. I can use the buttons to step through, into, and out of different code, trying to find my error. This is just a taste of the convenience a Python and Pyramid supporting IDE, such as PyCharm Professional Edition, can provide. In this section, we used Pyramid's configuration system to customize the handling of not found errors with our own view and template. We also looked at PyCharm's Professional Edition special Pyramid support to see what it provides. This is the first of several sections that look more closely at templating and static assets such as CSS. In this section, we use template inheritance to set a base layout across all our templates. Also, we use the popular Bootstrap project to improve the styling of our site. It's always best to take a look at the result first, making sure you are in your virtual environment, run pserv, and visit the URL in your browser. While the functionality hasn't changed, the styling looks much nicer. We have a header toolbar on every page, which lets us click a link to get back to the top. The fonts are nicer and the buttons are buttony, thanks to Bootstrap. For the code, let's start with inheritance. The Jinja 2 documentation gives a good definition. The most powerful part of Jinja is template inheritance. You build a base template, and then you have child templates which override defined blocks. Thus, we need to create a base template, then refactor each of our child templates to fill in the blocks in the base template. In our templates directory, we've added a base.jinja2 file. It's a full HTML file with a preamble at the top, a head, and a body. We define two named blocks that child templates should fill: block title and block content. The title will be filled by the child template for that particular view's title, and the content will be filled by the child template for that particular view's content. Note a technique in the title. The first part of the site title is for the particular view, then a dash and a string where part of the title value is site-wide. We'll get to the Bootstrap parts in a moment. Let's look at each of the templates to see how much easier they are with most of the repetitive HTML markup moved to base.jinja2. First, let's open list.jinja2. As is clear, this file has much less of the HTML boilerplate. First, it uses Jinja2's extends to provide the file name of its parent template. The Pyramid under Jinja2 package provides a number of useful facilities for looking up templates in rich ways. Next, let's see how this to-do list view template fills the blocks in the parent template. The title block is filled with the string to-dos list, which combines with the string in base.jinja2 to result in to-dos list space dash space my site. We see this on the second line. Also, the content block is filled with the markup unique to this view, a button for adding a new to-do, and a table for listing each to-do and the actions. This is the block for the content, and it ends at the end of this template. The other templates follow a similar pattern. The add template is now very short, and it chooses which it extends, what is its parent template that is, and fills 2 blocks. The edit, very similar. The not found, very similar. And the view, very similar. Template inheritance has really decreased the work. Next, let's take a look at the changes we made to get nicer styling from Bootstrap. Let's start with the base template. In this template, we have a link to the URL for the Bootstrap CSS style sheet. Just this step alone gives us nicer defaults, such as fonts. Next, we have a nav element to act as a global toolbar. Bootstrap makes this very easy. We use it to have a link that takes us back to the root URL, this link. Finally, our content block is wrapped in a div with a class of container. Bootstrap uses this as the fundamental unit for its layout. We aren't using any of Bootstrap's JavaScript components. If we did, we would add a line at the bottom of this master layout template down here to include the JavaScript on every page in the site. Our child templates also get some Bootstrap treatment. In list.jinja2, for example, we are using button styling to make a link look like a primary button. Also, we add the pullRight class to push this button to the right side of the container. Finally, our table gets CSS classes added to make it more attractive. This section makes our development much nicer by using Jinja2 template inheritance to dramatically reduce the size of our templates and let us focus on the problem at hand. With Bootstrap as the basis for styling, we also get more attractive, responsive pages. With our master template in place, we can show more about templating. In this section, we introduce looping and conditionals in Jinja2 templates. We also use dummy data to drive our to-do list. Let's start with a walkthrough of the result. I'll run the server, visit the page. We now have 2 to-do items in the table. Viewing a to-do actually gets data for a to-do, including an ID and a title. If you edit a to-do, the title actually changes and a message is displayed. Let's take a look at the code for this. All of the changes are in our views.py file and the templates. Our views.py file has some dummy data at the top representing a database of to-do items. We do this at module scope so that changes to the data persist between requests. Again, this is just for illustration. In a regular system, you would be using some kind of database system. In this case, the data is a dictionary with IDs as the keys and dictionaries of to-do data as each value. The first major change is in listing the to-dos. Our list view needs to get the to-do items in a format that is friendly for the views template. We flatten the dictionary into a sequence using .values. We could have used a Python collection, like ordered dict, done some sorting, etc. But for now, we keep it simple. Also, if a message was found in the URL, we extract it and provide it to the template. We'll see the message in a moment. The list.jinja2 template file has some important changes. Our HTML table now needs a row for each to-do item passed in from the view. We use a Jinja2 for loop to grab each of the to-dos. Where did the to-dos come from? They were part of the return value from the view method, to-dos. That makes it available in the scope of the template. Each table row then shows to-do information, such as to-do.id and to-do.title. Notice that we are using attribute syntax, .id, instead of dictionary syntax. Jinja2, like other template engines, lets you access dictionary keys as attributes. We also see other Jinja 2 control structures. In this case, the conditional if. Not every request will have a message on the end of the URL. We only want to display this markup, this div with the alert, if the view passed in a valid message, which was part of the return value from this view function. Jinja 2 has excellent documentation on all the control structures. Here's the for loop, here's the if, writing macros, call, etc. Next, visiting a to-do to view, edit, or delete it now gets back an actual to-do. Our current property on the view gets the ID of the to-do and tries to fetch the to-do item from the quote-unquote database. If it isn't a valid to-do, we raise a pyramid not found exception. If it is a valid to-do, we return it. This means our view and edit views are much simpler. They just provide the current to-do. Our view.jinja2 template shows the change. We are now getting the ID property or attribute from the to-do that is passed in by the view function. We could also change the title block to give the title of the current to-do that we are sitting on. Finally, our edit handler actually edits, setting the value of the title of the current to-do to be the value we passed in on the form. One addition on this, our route under URL, which is Pyramid's way to dynamically generate a URL for a route name, has an extra argument on it under query. The under query argument to route under URL adds information to the generated URL after a question mark. Our to-do list is now data-driven, although very incomplete. In this section, we show Jinja 2 control structures with data-driven lists. Modern websites are more than code that is executed on the server. CSS files for styling, JavaScript files for execution in the browser, images. While these are all static, they are still part of the final web app in the browser. In this section, we look at Pyramid's support for static assets. Pyramid can manage the reading of these files and efficient delivery to the browser. But more than that, Pyramid provides some useful facilities for organizing these assets in larger applications. As usual, let's start by viewing the result. I'm running the server, and when I reload in the browser, I see a different looking site. We have different styling from CSS, which we can see by looking at the CSS file in a new tab. Also, the URL space is reorganized. I have a home page, and then I have to-dos that are under a prefix of to-dos. So each to-do item, instead of /1, is /todos/1. Over in our code, we'll start with one change in our under init.py. Here we have called config.add_static_view. As mentioned previously, under init_py is a common place to make your configuration calls. Our goal is to have an area in our project where static files can be served to the browser. By static, we mean files that will not be interpreted or executed by Pyramid. These can be CSS style files.css, JavaScript files.js, images.png, etc., or even PDF and Word files. In a nutshell, we want a part of the URL space to map to a directory on disk. For this web app, we would like the URL space under /static to map to the static directory inside of our project. Here is the static directory under my site. Let's open that static directory, and you can see the CSS file and a fave icon. This file, mysite.css, is the same content you get when you go to /static/mysite.css. That is, the URL /static maps to the directory mysite.static. How does Pyramid do that mapping? We have already seen the concept of views in Pyramid, in which a URL executes some code. Pyramid has a special kind of view called a static view. Let's look at the pyramid docs for this. Serving static assets, add static view. With this, Pyramid has built-in support for finding, reading, and returning files on disk without you having to write any code. You just have to configure it using the configurators add under static under view, which is this function. The first argument, name, is the URL prefix that this static view should serve content under. We want /static. We could have said /mysite under static or some other prefix. The second argument, path, is the place on disk with the directory. This part gets interesting and powerful. Our value for path has a colon in it, mysite:static. Obviously, this isn't just a directory. Where does this come from? Pyramid has a system, a special system, called asset specifications. These are the docs for understanding asset specifications. As explained, a string value of something, colon, and then string after that is split into the package name, Myapp, and the asset name, some path within that package to get to it. How is this useful? For two reasons. Imagine you want to include the CSS from another Pyramid package using the link tags href. You don't want to worry about what URL prefix it is served under. In fact, you want the freedom to change the prefix without finding all of the then broken URLs in your templates. With this syntax, your templates generate a static URL dynamically. Let's look at that. Here is where I insert my site.css using a static URL with an asset specification, mysite:static mysite.css. In the add static view, we have said the package : directory. With this syntax, your templates generate a static URL dynamically, and because of this, you never have to worry about the URL path to your static assets. How do we put this static asset to use in our styling? We now have a CSS style sheet in our project. It was included in the base.jinja2 template using the link that we just saw. This will apply to all child templates in the site. To put this to use, we needed to add a div wrapper on the content block with an ID of content. And here we did that. This ID of content matches this CSS rule, #content. Finally, we made an important step towards a larger, well-organized system. We reorganized our URL space and put to-dos under their own URL space of /to-do. Where did we do that? We changed our add routes to have a slash for a home page, and then our 5 routes for the to-dos under /to-dos to get the listing, /to-do/add for adding, etc. With this, we added another view for a home page, which is distinct from the to-dos, to serve as the home page at /. This is the route for that. And here is the view for that route name. Our templates don't contain hard-coded strings for the links. Instead, they all use route under URL to generate the link. Thus, nothing in the templates had to change to reflect this new URL structure. We could just change it in one place, and all of our markup reflected that. We also had to make a small change to the not found template. Since we serve more than to-dos now, we need an error that isn't specific to to-dos. We say the page is missing instead of the to-do item. This section was a lot of fun, showing web development practices for serving CSS and JavaScript. We also took a peek at how the configurator can help you build composable systems, a topic we will look at more in later sections. So far, we've been using Jinja2 for templating by means of the Pyramid under Jinja2 package. As explained previously, Pyramid doesn't prefer or even provide a templating engine. In this section, we look at adding Chameleon, another first-class templating engine with high-quality Pyramid bindings. First, let's take a look at the page for Chameleon. This page is on the Read the Docs site and has very good documentation on the background of Chameleon and why it's different. There's also a page for the Pyramid under Chameleon package, which integrates Chameleon into Pyramid as a first-class templating engine. For the sake of completeness, Mako is another popular templating engine for Pyramid projects, as it was used in pylons, an antecedent of Pyramid. This is the page for Mako, and this is the page for the Pyramid under Mako package, which integrates Mako into Pyramid. Now, let's add a Chameleon-driven view to our existing project. If it is required for our site to operate, then it goes into setup.py as a software dependency. So I'm going to add to my requires line Pyramid under Chameleon. Since we changed setup.py, we need to rerun pip in our project. I'm in my virtual environment. You can see that in my prompt. Same line we've been using repeatedly. So we now have the Chameleon and Pyramid under Chameleon software installed into our virtual environment. As a note, our project configuration file, development.ini, has a debugging knob for templates that we saw previously. Pyramid.reload under templates equals true. This setting applies to all well-integrated Pyramid renderers, which includes Pyramid under Chameleon as well as Pyramid under Jinja 2. The Pyramid under Chameleon Python package is now in our virtual environment, but we haven't told Pyramid to use it as a renderer. Just as with Pyramid under Jinja 2, this is a config.include line in our init_py. Here's the line we did previously for Jinja 2, and this is the line we'll need to do for Chameleon. The config.include line tells the Pyramid under Chameleon Python package to run some Pyramid initialization, that is, registering a renderer for Chameleon so that template files with a .pt ending will be rendered by Chameleon instead of some other renderer. Our project can now use Chameleon templates as renderers. Let's add a new view that uses it. We'll make this an about page in the site. We need a route in our init_py. Here's our route, so that the /about URL will lead to the about route name. Next, our views.py file needs a view for that route name. Here is the route name about. Here's the view method about. And we now have a renderer templates/about.pt. The PT ending, short for page template, is the signal to use the Chameleon renderer instead of the Jinja 2 renderer. Let's take a look at that page template. This is the template file for this Chameleon-based view. Looks pretty similar to the other page templates in the site. Slightly different syntax, $, curly bracket instead of double curly bracket for variable insertion. Running pserv lets us go to the /about URL in our browser. I'll go to my browser, go to the top of my site, and I will add /about. And I see the rendered results of this template. Heading with the word about, and a paragraph with the label URL and the value of the current URL as fetched from the Pyramid request. This page in our site does not have the global look and feel that we see in the other parts of the site with the toolbar, etc. Why not? Let's look again at the Chameleon template in about.pt. Our Jinja 2 templates extend our base template in base.jinja 2. For example, the home page extends base.jinja 2. We can't do that here in the Chameleon template, as template inheritance does not work across template engines, meaning a Chameleon child template can't fill blocks and extend a Jinja 2 parent template. Pyramid's pluggable approach to template engines and renderers lets it handle some hot new flavor of the week if a popular new template engine is released, or an antique one. Long ago, I added XSLT as a renderer. The youthful days of exuberance. Here's the documentation on adding a new renderer in Pyramid. As an extra case, you might want to customize or extend an existing renderer, such as Jinja 2, in some way. You can register a new renderer based on the existing one and implement the custom semantics for your project. That is, you don't always want to use this facility for adding a new template engine. You might want to customize an existing one. In this section, we looked at alternative template engines in Pyramid. We won't be using this in future sections, but rather simply showed the topic for completeness. Our To-Do app has add and edit forms for modifying the data. These forms are currently laid out manually. Modern web frameworks, though, provide automation of form handling and validation. Pyramid, true to its only pay for what you eat philosophy, doesn't bundle a forms package, just like it doesn't bundle a template engine. In this section, we look at the popular Deform package written by the creator of Pyramid. Deform combines with Colander for schemas to provide form generation and validation. This section covers generation of forms. Let's start with the documentation page for Deform. This explains the background, which templating engine Chameleon uses for its rendering, and its relationship to Colander for schemas. Colander is a Python package independent of Deform or even Pyramid that can be used for purposes related to schemas of data. As a note, Deform and Colander's approach is to have schemas for your forms, not auto-generating forms from your data model. Invariably, you have forms with extra policies apart from your data model. Show this on your edit form, don't show this on your add form. Form schemas should be for describing the form, not the data, which might have many forms. There are, however, packages such as CRUD which do this. Automatically generate Colander schemas based on SQLAlchemy mapped classes. Let's start by reviewing the completed system. I will go and start my server, and now go to my web browser and navigate to the top of my site. I will go to the to-dos and add a new to-do, and I will edit a to-do. This shows actually editing. Adding we will save for later. Back to the code. We need to add Deform and Colander as software dependencies. That means opening setup.py. I have added in my requires a software dependency on Deform, but we're seeing something we haven't seen previously. I'm stating that we want to use the version of Deform greater than or equal to this version, 2.0 alpha 2. Since Deform depends on Colander, we don't need in our software to specify a dependency on Colander. Installing Deform will automatically bring in that dependency. Now when I install, I will get the Deform package and all of its dependencies installed into this virtual environment. Deform 2 has been stable for a long time, hence this dependency, but hasn't released its final version. We'll use this new version, Deform 2, in this section as it has nice integration with Bootstrap, the CSS system we've been using. We have one change we need to make in init_.py. Deform also needs jQuery loaded into our returned HTML. We do so for all views in the site by putting it at the bottom of our base.jinja2 template, thus ensuring each child template will include it. And here's that line. Like the Bootstrap CSS in the head, we are serving this from a Content Delivery Network, or CDN. With Deform now available, let's look at our changes to put it to use. We need a schema to describe our form, and then we need to integrate our form into our views and templates. Our Colander schema is in views.py. We have some import statements. We import Colander, and we import form from Deform. And here is our to-do item schema. This to-do item class, to-do item, subclasses from something in Colander called a mapping schema, which gives it most of its behavior. Our schema is simple, saying that our form will have a title field, and this field is a string. Because this field is not defined with the optional missing attribute inside here, the form will require a title value to be provided. The constructor for our view class makes, on every request, an instance of this schema. In the next line, we make a Deform form using that schema as the form definition. We also have one button for submit. Our add form is a good first place to see this in action, starting with the HTTP GET to initially load the form. Here's our view. This is relatively simple. On first load, render the form as markup and make it available in the template as the add under form variable. And we see rendering the form and assigning it to the variable. Our Jinja 2 template that handles the add form now has a variable add form, which comes from the view. This is what we had just returned, and it contains the rendered form. We tell Jinja 2 to insert the value of add form, but we pass it through Jinja 2's safe filter. In Jinja 2, you can have filters separated by a pipe symbol, where the output of one side, add form, is piped into the filter. In this case, the safe filter allows us to insert markup without Jinja 2's default practice of escaping the HTML. There are many Jinja 2 filters that are useful, such as sorting. That gets the form into the page. What happens when the form is submitted? Our add under handler view is used for HTTP post to that route. This is the add handler to the to-dos add route. And this is called when the to-dos add route is a request under method equals post. That is, this is the self-posting form pattern we've seen previously. Our add handler doesn't yet get the data out of the form and validate it, as we will be doing that in the next section. Our edit under handler view is similar. In this case, though, we want the form to contain the existing values. When we do the form render, we're going to pass in the value of self.current. Self.current is the current to-do item that we're sitting on. This means when rendering the form, we supply that to-do in the render and get the current value for title to show up. Using this in the template is very similar to how we did for the add form. We have a variable available from the view, and we pipe it through the safe filter to prevent HTML escaping. We make one small cosmetic change showing in the heading of the ID of the to-do that we are editing. Here we insert the value so we will know the ID of the one that we're editing. As a note, we also made the same change in the view.jinja2 template. While we're at it on cosmetic improvements, let's make the listing of to-dos less wide. We did this by adding a Bootstrap CSS class in the list.jinja2 template, this class. In fact, we switched over from an HTML table to a Bootstrap list group, and we made our edit delete links into nicer looking buttons. This is the list group CSS class, which turns an unordered list into a Bootstrap list group, 6 columns wide, where every list item is an entry in the list group. And here we have edit and delete, where edit is a button instead of just a link, and it has an icon with a pencil decorating it. In this section, we've laid the groundwork for forms handling in Pyramid by introducing calendar for schemas and a form for form generation. We'll put these together in the next section and do form validation and processing. Presenting a form generated from a schema is only half of the work. We need to get the data out of the form with values converted to the types we want. We also need to enforce validation rules. In this section, we used a form and calendar for form validation, changing our views to handle these cases. Let's show validation in action by previewing the results of this section. In our virtual environment, run pserv to start the Pyramid web app. Adding and editing a to-do item now includes validation. If you don't supply a value for a title, you get an error and your changes are not processed. Let's look at this in our web browser. We will add a to-do, but I will leave it without a title and see that I have an error. If I go to edit a to-do and remove the title, I see I have a validation error. In our views.py code, we first need to import a special exception type from deform. This is the exception validation failure. We use this by using standard Python exception handling, which allows you to define a new kind of exception class, shown here as validation failure, and then if that is generated by deform, we in our code can handle that exception. If you don't supply a value for a title, it will generate that exception due to the schema. The only major change for the view code is in our add and edit handlers. That is, the views that accept form data by HTTP post. Let's take a look at our add handler. We now have a try and accept handler for validating the data in the controls. That is, we extract the raw form data into a variable called controls. We process that form data against the form and schema by calling validate into a variable called abstract. If processing the form data results in a validation failure, a special kind of exception, then return the form with an error message. The form is not valid. We're going to return the add form. The add form will then be in a state where it will show the error message and the previous value. If validation succeeded, then the abstract has the raw form data converted, though, into Python data via rules in the schema. For example, our schema says that the title is a string. If it said that it was an integer, then we would get the string from the raw form data converted to an integer. Since we have the abstract, we can get the new title from the abstract with any conversion that was done. One other change in views, we centralize collecting and displaying a message. That is, we use the view class's constructor under init to extract a message from the URL and assign it to the view. Why not do it as a property the way we did current? Because we're moving the HTML for this message into the base template and thus need it to be calculated on every request. Thus, there's no need to do it in a lazy fashion. Here is our base template, and we now say if view.message, if there is a message that was extracted from the URL, then show it. Again, view is an instance of this view class, so view.message was assigned here. In this section, we took the second step on forms and did form validation and conversion using deformed forms and colander schemas. Our MySite application so far has operated on data, but only in memory. Web applications are database-driven, with many using SQL databases. In recent years, web development has centered on ORMs, short for Object Relational Mapper. An ORM makes working with a relational database seem natural to a language such as Python. SQLAlchemy is the premier ORM for Python, and Pyramid works very well with SQLAlchemy. In this section, we'll add database support via SQLAlchemy by installing and configuring the Pyramid under SQLAlchemy package. This package automates setting up SQLAlchemy in Pyramid. In the next section, we will set up our data models and integrate into our views. We have new software dependencies, so let's change setup.py. Obviously, if we're using SQLAlchemy, we have a dependency on a package which gives us SQLAlchemy. Here you see that line. But what's Pyramid under TM? Short answer, the TM means transaction management. The Pyramid community has a strong heritage in pervasive transactions. This manifests itself in a transaction manager which handles each web request as a transaction. That is, an incoming request starts a transaction and an outgoing response closes it. If nothing went, quote, wrong, then all integrated databases commit their work. What does wrong mean? Let's take a look at the documentation for Pyramid under TM. And transaction usage explains the various scenarios for what can happen during a transaction. While we're on this page, let's show the SQLAlchemy homepage, the Object Relational Mapper. Great documentation for this project. A long history of releases, bug fixes, new features, support across databases. In this project, we will be using the SQLite embedded database. Back to Pyramid under TM. Simply stated, this means you don't have to begin and commit transactions in your typical coding. Any error anywhere, including in a template, will abort the transaction. The Pyramid under TM package is now in our virtual environment, but we still need to include it into our application. This usually means a config.include line in our init under.py wiring file. However, let's look at this a bit differently. Our software will actually run okay without a transaction manager, but requests won't commit any data. In some cases, you might want that, for example, a test server, or if you're in debug mode on a production site. Thus, rather than putting transaction management in our software, let's put it in our configuration file. Pyramid configuration files can have a pyramid.includes value, which supplies packages, one per line, which should be config.included into the configuration. We added a line for pyramid under TM. This has the same effect as doing something like in init doing config.include pyramid under TM. So that would be the same thing. We've just moved it over to the configuration file so that we can turn it on and off in configuration rather than software. Our configuration file also needs a line to configure SQLAlchemy's data source. The pyramid under SQLAlchemy package will look into the settings, and if a value for SQLAlchemy.url is provided, as we have here, it will initialize SQLAlchemy with that engine setting. As shown, we are using the SQLite embedded SQL database in a file stored relative to the location of this config file. That's the % here variable substitution in this string. So the file name will be mysite.sqlite. This will be created on Pyramid Startup. Finally, we have some setup left to do in under init. We have to add an import of SQLAlchemy and its metadata package. PyCharm is helpfully telling me that it can't find this because I haven't done our routine. Once we have this metadata package imported, we also need to include pyramid under SQLAlchemy. Our software will not work without pyramid under SQLAlchemy, so we do it here instead of in the configuration file. Finally, after our config.scan, which goes and looks at all the files in this project for pyramid configuration directives, we tell the SQLAlchemy metadata to create under all, meaning go and register all of our models, which we will see in the next section, with the SQLAlchemy object relational mapper. Doing this registration after the config.scan gives our packages a chance to import those models. Once imported, SQLAlchemy will do the rest, if we do this create all line. If we now start up Pyramid with pserve, then we'll see the creation of the SQLite database file, mysite.sqlite, in our project directory. This section covered much of the theory and setup for using a database in our web app. In the next section, we define our database models and start using database data. Let's get serious and work with the database. Our SQLAlchemy setup and connection to the database is in place. In this section, we define our models and learn to write a pyramid console script that bootstraps our database. We'll then change our views to operate against that database. First, let's look at our SQLAlchemy models. That is, the Python objects used by the Object Relational Mapper, or ORM, to represent and integrate the database data as semi-native Python objects. We define these models in a models.py file. This module imports some column definitions from SQLAlchemy, then has a to-do class representing a to-do table in the database. This is the class, subclasses from something available in Pyramid under SQLAlchemy, and creates a table name of to-do in the database. This table has two columns, an ID column as the primary key with a value that is automatically assigned if not provided. Also, a title field representing the value we have been typing into the form. Finally, we have some sample data to speed up development, because often we will be dropping the table, removing our database, starting over from scratch, and we don't want to type in some sample data every single time. How does this table get created? We saw in the previous sections that the database file itself gets created, but doesn't contain any table definitions or data. In Pyramid, the most common pattern is to write a console script that you can run to initialize your database. Here's the documentation for command line Pyramid and writing scripts that do work. Pyramid uses the same Python packaging convention of entry points to implement Python-based console scripts. Let's take a look at our setup.py. We see the new console under scripts section with an entry point for our console script. The left-hand side gives the file name, initialize under DB. This file name will be generated in our virtual environment bin directory, thus making it available. The right-hand side is the path to the callable main. that should be invoked by this console script. We change setup.py, which means we have to run pip again. When we run pip again, this generates the initialize under DB script, the console script, the file name we defined here, in our virtual environments bin directory. Here I see initialize under DB. Let's take a look at what was generated. This is not some binary, it is a simple Python file. It is a wrapper around the actual work that we are doing in the callable that we pointed at. Let's take a look at that callable. We said it was going to be in the MySite package in the scripts directory, and there was going to be a file called initialize under DB with a function main. Let's go find that. In MySite, we have a directory called scripts, and there we have a file initialize under db.py. This is our console script. It does quite a bit of work. Let's take a look at some of the things that it does. It has a number of imports to get into Pyramid and Pyramid's configuration system. It needs to get connected to SQLAlchemy, and it needs to be able to get the settings from our configuration file. And then finally, it needs to import our models and our sample data. We see a fairly standard set of boilerplate for getting arguments from the command line, and then the callable main that is in the entry point is going to set itself up, and then inside the transaction manager, it's going to create the SQLAlchemy metadata, and then create to-do items and add them. Let's execute the console script to generate our database with both the tables and the sample data. First, we will run initialize DB without any arguments and see that it gives us the error that we defined in usage. Now we will run it and point it to a development.ini configuration file, and it runs to completion. If I run it again, it should fail because the database already exists. If I delete the generated database file, and we can see it here, mysite.sqlite, perhaps I've changed my models, I've changed the data, I want to start over, I just delete the database and run it again. All of this is running inside the console script that we have defined here. It's running inside something called a context manager in recent versions of Python, the with statement. All the code inside this block will be running inside the transaction manager as a Python context manager. It will do all of this work, and then the transaction manager, which we discussed in the previous section, will commit if everything goes right. So good, we have a correctly populated database. As a note, if we configured Python standard logging to show debug information, we would have seen the SQL being executed. We'll do that in a later section. Also, note that you need to run this whenever you change your schema definitions. Do we really have data? Let's take an interlude to show how PyCharm can explore databases. PyCharm has a database tab, and I can add a new database. In my case, it will be a SQLite database. I will go and get the file. Here's the SQLite file. PyCharm is warning me that I need the driver downloaded, which I've now done. I can test the connection. It's happy. I will save this. And now I can explore my SQLite file, my to-do database, and I can open the table browser and see the sample data that I put in. Very helpful when working with databases in development. As a reminder, I will go and disconnect from that database so it doesn't interfere with the application server that I'm going to be running. Let's get these models into our views. In our views.py file, we start with some imports, SQLAlchemy session, my to-dos. Session is a convention used by Pyramid under SQLAlchemy to wrap the underlying SQLAlchemy machinery in a convenient accessor. We also import our to-do model. Our list view needs to change. Instead of returning dummy Python data, let's do a SQLAlchemy query and return the result. Here's our list view. Previously, we returned the sample data. Instead, let's go to the session, do a query for all to-do models, and just for fun, let's sort based on the title of those to-dos. Next, our @current property was getting whichever to-do item we were currently sitting on in the URL from the sample data. We need to do a query to get that. Here is our current property. It's going to get the ID out of the route, the matchstick. Since our schema our to-do object's ID, define this as an integer. We need to convert the string for the URL into an integer, and then we can do a query in the database for the to-do model, and we want the ID value for that column to equal the to-do ID that is in the URL, and then run that query and get exactly one result. If we get none, we raise a not found like we did previously. Otherwise, we return that data. That's the only change that we need to do for that. Our edit view needs to access the existing value of title to put it in the form for editing. Let's go down to our edit handler. We previously did that by passing the @current to do, which was a dictionary. The form wants a dictionary, but SQLAlchemy returns an object. So we have to convert that SQLAlchemy row into a dictionary. We do that here with a dict before rendering the form. Next, our handlers are largely similar, but we need to save to the database. For example, in the edit handler, we will get the title from the form, assign it to self.currentTitle, and that's all we'll need to do. The add handler is a little bit different. We will get the title, create a new to-do with that title, and use session.add to add it to the database. Once it's added to the database, it will get an ID. Those are automatically assigned, so we need to query the database so that we can get that ID and redirect to the new to-do. Last up, in views, we change our delete view to do a database delete. The current to-do is deleted using session.delete, and then we do a redirect to the to-dos list. Note that our view code operates on the database, but there are now transaction begin and commit statements. This is Pyramid under TM in action. When the response is going out the door successfully, Pyramid under TM commits or rollbacks if necessary. We didn't have to do anything in our view code. Now that we have all this in place, let's take a look. We have already run pip to get dependencies and generate our initialize under DB console script. We also ran that console script, giving us a SQLite database file that is properly structured along with some sample data. All that is left is to run pserv. In our browser, we go to the top of the site and click on to-dos. We are seeing a listing of our sample to-do items from the initialize under DB console script. However, we can now add, edit, and delete. Let's add a new one, and we see it listed in alphabetical order. If I edit that and say a to-do and go back to the to-dos, we see it in alphabetical order. I can delete get eggs. And the big difference is if I stop and start the server, my changes are saved to a database rather than being discarded because it was only working in memory. There we go, a working database-driven system for managing to-do items. In this section, we covered defining our to-do model, making a console script to ease setup, and integrating the database into our web apps views. We're now using a database. Modern web development also includes, though, another kind of storage known as sessions. A session is a bit of transient data that isn't a part of your core data model, but facilitates certain user interactions. In this section, we'll use sessions to display flash messages to replace packing our message information at the end of the URL. As stated repeatedly, Pyramid has an only pay for what you eat philosophy. This also applies to sessions. Pyramid includes basic sessions support, conforming to a pluggable interface allowing you to swap it out for an industrial strength add-on or a custom sessioning strategy. This is illustrated in the Pyramid documentation for sessions. As discussed, Pyramid can be used for flash messages, for things like cross-site request forgery, CSRF, and you have an implementation that's the default with a big old warning saying that it is unencrypted. You should only use it for development. But there are alternate strategies that can be installed that conform to the same interface. You just develop with this, and for production, you replace it with something custom to your needs. Let's first look at it in action. Just as a refresher, we'll start from the top and show the entire sequence for getting started in a development sandbox. I'm not in my virtual environment. I don't have anything on my prompt saying so. Now my prompt changes. I need to install my software. This will put me into development mode, and this gets me the extra requirements beyond the setup.py, which are part of my deployment. Goes out, gets all of those. Need to initialize my database. And now I can start my server in reload mode. Going over to my web browser, let's show this in action by going to localhost 6543. Go to my to-dos. I can add a new to-do. And when I do, I see a flash message here without information being added onto the end of the URL. This uses the sessioning strategy. So let's take a look at this session-based implementation. First, the built-in sessions use a secure cookie that is signed with a server-side secret. Is the secret stored in the code? Nope, not a good place to put it. Instead, it goes in the configuration file for this site, meaning the development sandbox. Our code reads this information from the configuration file, the value it's a secret, and then makes it available in the configuration. Let's see how that's wired up. We start with some new imports. We get the secret from the settings. This value, session.secret, is the key that we used in our configuration, and thus we get the value back and assign it to this variable. We make a session factory that conforms to that pluggable interface using that secret, and then we tell the configurator via session factory to use this value, the signed cookie session factory, as our sessions for this site. After this is done, Pyramid's request object now has an extra piece of information, request.session. We can use this now in our views.py. Our view class previously extracted in its under and init under constructor the message from the URL. It did so in here. Let's change that to get the message, if any, from the session. Here's where we get the message now. Instead of getting it from the URL, we get it from the request.session. Sessions operate as a queue that you push and pop items onto. For example, our add handler view changes to push a message onto the sessions queue instead of adding it to the generated URL. The add handler adds a message to the queue with this value, a flash message. This is the same for edit and delete. The edit handler calls the flash method on the session to put another message into the message queue, and delete does the same thing. When you call request.session.pop under flash in our view constructor, we have one other change to make. The result of calling this gives you back a list, perhaps empty, but perhaps with multiple messages. Our template to insert the message, thus, needs to handle a sequence instead of a single message value. Let's see the change in our base.jinja2 parent template. We test to see if we have any messages, and if so, we do a for loop over each of the messages and display them. Just for fun, let's show the session on the request using PyCharm's debug support. We'll set a breakpoint in the view class constructor and run Pyramid under PyCharm. Here's the breakpoint. I have a run control setting already in PyCharm. Instead of clicking the green to run it, I'm going to click the bug to run this in debug mode. It's going to fail the first time because I didn't stop the other process that's trying to use the terminal. So I'm going to close this. It's using the port number 6543, so I have to stop it. And now I can go back and run the debugger. It will say it's running. I can go to my site. PyCharm will stop the processing of the request at this point, and I can see that the request object now has an item on it called session. It is an instance of cookie session, and I can inspect the values that are on there. For certain kinds of web apps, particularly those with high scale or security requirements, sessions can require sophisticated or even custom engines. In this section, we saw how you can start with Pyramid's basic bundled session support for development, and then later plug in your own custom session support. Many modern web apps have logins with usernames and passwords, either for personalization or for managing content. In this section, we look at authentication, the first half of Pyramid's security story. This page shows the documentation for Pyramid's security story, including authentication and authorization. Pyramid's security story, including authentication, comes from a long history in rich web applications. This history includes many lessons learned over the decades, leading to a rich, pluggable system. We will start with the default built-in cookie-based authentication system. Let's begin by reviewing the running system with authentication enabled. I will go to my site, click on my site to go to the top. We've added a login link, and I can come over and use editor, and I'm now logged in. The login link is changed to log out. I can click on log out and lose my authentication. Let's take a look at the code. First up, we wire in authentication in our init under.py. We add two imports at the top for authentication and authorization, getting policies that ship with Pyramid. We then add an import from one of our modules for a callback function named Group Finder. This is a function used by the security policy to convert credentials into principals. We'll look at this function in a moment. Our init also adds two routes to handle login and logout views. Finally, close to the bottom, the important part. We tell the configurator about our security policies by instantiating an authentication and authorization policy, then adding them to the configuration. Here I create an authentication policy. Here I created an authorization policy. Both of these are based on imports that we did at the top from core Pyramid authentication authorization packages. And then we tell our configurator to set the authentication policy and set the authorization policy. Our authentication policy takes three parameters: the callback, the hash algorithm, and the server-side secret for signing the cookies. This is similar to the session setup. We need to add something to our configuration file. Here's our .ini file, and just like we had a session secret, we now have an auth secret. Now let's take a look at the security.py file containing our configured group finder function. This is a simple callback function. The security policy decodes the credential information in the incoming request for us, in this case from a cookie, then calls our function, providing the user identification it decoded. We are then responsible for looking that up in whatever system we have. If we find a user, then we return a list of principals, the username and any groups. Note that this part does not cover validating the password. At this point, when this callback is called, the user is already logged in and has the token representing their credentials, meaning their user ID. Login is covered in our views. We added a login view, but at the top, we had to add some imports from Pyramid Security that help us with remembering and forgetting the cookie information. We also need to get from the security module that we just looked at the list of fake users that we are currently using. Here's the security module. Here's our list of fake users. We put this to work in our login and logout views. Our login view, when you do an HTTP GET, just returns the template. When you do a post, we have a login handler view. It gets the username and password from the form data and then does our security work. If the supplied username matches a user in our user database and that matched user's password matches the supplied password in the form data, then we're good. That is, we redirect the request to the site homepage. If those conditions are not true, we couldn't find a user or the password didn't match, then login fails, and we supplied a form error variable used in the login.jinja2 template to explain this problem to the user. Here's our form error. Let's go to look at our template, and we say if there is a form error, let's give them an alert with the value of that form error explaining the problem. Now that we have a login view, we naturally need a logout view. I'll go back to my views. Here is my route name for logout. Thus, this is my view for logout. We don't need get and post views, as logging out doesn't itself show a home page. It just performs some work and sends you to the home page. In this case, the work is call the Pyramid security policies forget function, which removes the logged in user's credentials by removing the cookie. Here's where we call the Pyramid forget function. One last piece of work to do. We need our UI to show in the toolbar the login and logout links. We'll do this in our toolbar header on every page, which means in our base.jinja2 template. We added a UL that will either show a link for login if the user isn't logged in, or if they are logged in, we'll show a link for logout. For this, we used a Jinja2 if-else control structure. If they're logged in, else we presume they're not logged in. Our test is whether a request.authenticated under user ID exists and has a valid truthful value. This is part of the Pyramid core security story that is supported in all Pyramid installations. We now have a simple system which tracks logging in and logging out with validated usernames and passwords. We haven't yet, though, done actual security. That is, protecting resources with permissions. That's the area of authorization, which we cover in the next section. We can now prove that someone is logged in with a valid username and password, thus becoming a principal. In this section, we show Pyramid's flexible and powerful authorization model for protecting resources with access control lists. Let's start by reviewing the finished result. I'll go to the home page of my site. I will log out, go to the to-dos. I'm allowed to list the to-dos, but if I try to add a to-do, it says I'm forbidden. If I try to edit a to-do, it says I'm forbidden. And if I try to delete a to-do, it says I'm forbidden. But if I log in as editor, I'm allowed to do all of these operations. How do we get this feature set? Simply stated, we need to introduce a security model. Fortunately, Pyramid has just such a thing, an authorization policy. In the previous section, we configured a basic authentication policy, but also an authorization policy as well, using Pyramid's default in Pyramid authorization policy. This explains the work that we did enabling an authorization policy. By default, all views are accessible. You add an authorization policy by importing the software, making a policy, and adding it to the configuration. Once this is in place, we can start making security statements. For example, a certain user might need permission to perform a certain operation, such as one of our views, add, edit, delete. In Pyramid, you enforce your security model by protecting views with permissions. Protecting views with permissions. For example, on this view, we added an extra piece of information called permission, defining what permission the user making the request needs to have in order to execute this view. Or if we're using a decorator instead of doing add view in the init. We have one more piece, though, that's needed. We have a way to issue credentials identifying the user or principal behind a request, and we have a way to say that a particular operation requires a particular permission. How do we connect principals to permissions? This is the job of access control lists, or ACL, a standard concept in security systems. Assigning access control lists, ACLs, to your resource objects. For example, this is a resource object with Pyramid's under ACL under saying that this object has a access control list on it. With this, our system gets to say which people have which permissions on which content. This group has the add permission on the blog content. Let's see how we implemented these ideas, permissions for operations and ACLs for resources, to secure the changes on our to-do list. In our code, we enabled a security policy in the under init under. This is the same thing we saw in the previous step, but we didn't put to use. The security policy is installed, but we've made no security statements. Let's say that all of the to-do-oriented views that make changes need a permission that we will call edit. I'll go to the views, and in the view config, for example, for add, I added permission equals edit. Note that this statement, users must have the edit permission to invoke the add view, is done outside of the view. We don't do it in our own view code. We do it in this decorator that wraps the view code. This is subtle but crucial. It means you, as a Pyramid developer, don't have to write security code. You configure it in your view config. but the work to enforce it is done by the pyramid framework before calling your view. Not only do you not have to write it, but you don't have to write the tests, fix the bugs, and perform detailed security auditing. You've outsourced this hard problem to the pyramid framework. That handles the permissions. Now we need ACLs on the content resources that say which users have which permissions on which content. Our content is accessed in a database. We said that security is enforced outside of our view before the view is called. We don't have a database object yet, a row from the database. So we can't put the ACL statement on the to-do model class. The simplest solution is to register a root factory with pyramid. This is a resource object that will be consulted by the framework before the view is invoked. First, we register the view factory. In our configurator, we supply a value for the root factory, which is a string. It can also be an imported literal. A string with a dotted path. Look in the resources file for the root object that supplies the root factory. Let's open that file and look at the implementation of this root factory. Pretty simple. This gives us a single ACL, access control list, for all of the site. The root object has an ACL, which is supplied in the root factory. This ACL says everyone, whether you're authenticated or not, is allowed to have the view permission, but the edit permission requires you to be in a group called editors. Pyramid has a number of facilities for implementing ACLs on different parts of the site, or even at the individual resource level, which we will look at later. For our purposes, though, in this section, this single ACL is perfect. We now have a way to say the following security policy. Adding a to-do requires the edit permission. The root object says which users are given that edit permission. Finally, we need to show a custom message when a user does not have permission to go to a view. Like the not found work we did previously, this is a special decorator you can apply to a view, registering that view with pyramid as what should be shown when a pyramid forbidden exception is generated. In my views, I have a new view forbidden that gets the decorator imported at the top, forbidden under view under config, with a template containing some boilerplate language. This section and the previous section gives us the cornerstones of a basic pyramid security model. Let's next see how to store users in the database instead of a dummy file. Our Pyramid web app handles users with passwords currently by storing them in Python code. That's hard to visualize. People are used to storing users in a database. In this section, we do so along with some other housekeeping. Here's what we'll do. Change from a single models.py file to a directory with a file per model, including a new user model. Modify the console script to initialize the database with a table for users along with 2 sample users. Have our authentication policies group finder callback look in the database for users instead of our code. And finally, change our login view to look up usernames and passwords from the database. Lots to go through in the code. Let's start with our models. We now have a models directory with 3 files in it. Here's the directory, here are the 3 files. The under_init_py is the control file for the models subpackage. In here, we put a utility class, array type, that we've added to have a new column type for SQLAlchemy to work around a limitation in SQLite, the database that we're using in development, for managing array data. This comment or docstring explains. Our to-do models haven't changed other than location of imports. We do, though, have a new model for users. In this model, we do much of the same work. We import some column types from SQLAlchemy. We get our base object from the pyramid integration. This is new. We're importing this new column type called array type that we just saw. We have a user model now that is going to be stored in the users database table. Each user will have an automatically assigned ID, a username, a password currently stored in clear text, a first name, a last name, and then an array of whatever groups this user is in, if any. And then finally, we have two sample users, Jill and Jack. We need to change our imports in the console script that initializes the database and add sample users as well as the sample to-dos we have currently been adding. So in the scripts initialize DB, we're going to import the users model and the sample data. And then at the end, in addition to adding our sample to-dos, we're going to add our sample users. If we run our initialize script now, this will result in an initialized SQLite database with those two tables and sample data. Just for fun, we can verify this result using PyCharm's Database Explorer. I'll delete the existing one, add a new one, SQLite. The file will be in my project. I'm going to test the connection. Connection successful. Apply. OK. I now see my schemas, and I have a users table, which I will browse, and it shows me the information for those two users. All right, good enough. Let's get rid of that. We have one change to make before looking at our views. Our existing authentication policy registered a group finder callback. Let's see where we registered that. Our authentication policy had a callback of group finder, which comes from our security file. Here is the group finder function, and we need to change that function to get users from the database instead of from sample data embedded in this file. That's what we do here. We use the SQLAlchemy session to query for any users and then narrow it down to the users who have a username value equal to the one passed into this group finder function and get just one of them. If we get no results, then we give up. If we do get results, then we return the groups that are stored on that user. So the group finder function is now querying the database to get the user group information. With this in place, we just need to change our login view to compare usernames and passwords in the form data with users in the database. I'll go to my views and I'll go to my login handler. And here we get the username and password out of the form data. And this time, instead of getting the user from importing the dummy database that we used previously, we will actually query the database, similar to what we just saw. We say if we did get back a user and that user has a password, meaning the database user has a password column whose value equals the password from the form, then we have a valid user and we run the same authentication policy machinery we did before to store the authentication cookie. Again, we could employ an encryption function here to encrypt and decrypt the password so that we have encrypted passwords in the database instead of clear text passwords. And that's our coding changes. Let's take a look at our working system. Over to my browser. If I log in as Jill with Jill1 as the password, then I have successfully logged in using a username and password that was in the database. Here was Jill, and Jill1 is the password, and this is her groups. Jill is allowed to add a to-do, but if I log out and log in as Jack, Jack is the username, Jack2 is the password. Jack is not allowed to do that. Why? Because Jack does not have the editors group, and from our ACL, you have to be in the editors group to get the edit permission. And then the last step, adding the add handler, is protected with the edit permission. Jack was not in the group that had the edit permission. In this section, we moved to database-driven users while exploring some of the other aspects of organizing a pyramid project. Our system has a root factory applying a single access control list to the entire site. While this is already useful and could be extended in many ways, wouldn't it be better if different kinds of resources had their own ACLs? In fact, if you could change the ACL on a single database resource? In this section, we introduce route factories. Like a root factory, this is a way to get an object before a view is consulted. Unlike the global nature of a route factory, though, a route factory is configured on a per route basis. Before showing the route factory, we're going to do some housekeeping. Our previous section split the models into a models subpackage with one model per file in that subpackage directory. Let's do the same with views by making a views subdirectory with an init under_py to turn it into a Python package. We'll then have files for our views. If you take a look at the My Site directory, I now have a views package, views subdirectory. It's a package because there's an init under_py. Even if it's empty, this turns it into a Python package, and I have 2 files in it for each of my views. The views are largely the same. They just remove the overlap needed to support both. As a small optimization, let's speed up the startup of our web app by having the configurator scan only this views subpackage looking for directives. Here's my package, my site init under_py, and the scan happens here. Previously, we had it with nothing, and it was scanning all the files in this project. With this change, it's only going to look in the views package, which is here. Since we're in the init under_py, we can start investigating our changes to implement route factories. Note that our configurator is now created without a route factory. Previously, we had an extra argument, route factory, etc. Instead, our to-do routes have an extra argument passed to them. These are our to-do routes with the route factory. These first 2 arguments are the same as they were before. We're adding an extra keyword argument on each of these routes to point to a string containing a dotted path. This change gives us a route-specific factory, one that can be targeted at the to-do data by retrieving a to-do-specific class instead of a site-wide route class. On the to-dos route, this one, to-dos list and to-dos add, we will want something generic as there isn't a row in the database representing the to-dos collection. Ditto for the to-dos under add route. But for the other 3 routes, the ones with the ID in the route parameter, we want this factory to retrieve the to-do being pointed at by the ID in the route parameter. How does this route factory work? Let's open the function pointed to by the dotted path argument, this .models.todos.todo under factory. In models, to-dos, we have a function called to-do factory. This factory is a function which returns an object. The first job this factory has to do is decide whether the route is pointing at the collection /todos or /todos add or at the single to-do. If we are pointed at the collection, we will return the to-do class itself. But if we are pointed at a single to-do, we retrieve that to-do and return it, or raise a pyramid not found if we can't find a to-do for the ID in the route parameter. Let's take a look at walking through this code. We first get the ID. This comes from the route parameter right here. If there is no to-do ID, if the matchstick does not have an ID, that must mean we're in /todos or /todos/add. Therefore, it will be none, and we can return the to-do class. If, though, there was a matchstick parameter for the ID, then let's convert it to an int, an integer, because that's the way we store it in the column in the database. The ID is an integer. And then go do a query. Go ask the database for any to-dos filtered by that integer and give me the first one. If the response assigned to to-do is non-existent, then that means it couldn't find a to-do for that ID. Thus, we have moved responsibility for getting at our resource out of our view code and into the quote-unquote framework. Pyramid has a first-class concept for this pattern. An object which is retrieved as part of routing is called the context and is assigned to request.context. The context can be put to use in several ways, as we'll see in this section and in later sections. Our to-do model now has an ACL on it, similar to the root resource we had in the previous section. Here is our to-do model, and here is the ACL. In fact, we deleted the file containing the class for the root in the root factory from the previous section. Since the to-do class and its instances are the context for these routes, this ACL will be consulted by the framework for permission checking. At this point, our security model works the same as before. No change is needed in our view code. That's a benefit from using a framework which abstracts the security. We can, though, make a few changes to put the work in this section to good use. First, let's get a benefit from the context. We previously had a method on our view class to get the current to-do. We don't need that any longer, as context is the to-do, whether class or instance. That is, the framework has done that work for us. Let's change the views for the to-dos to reflect this. I will open the to-do views, and I no longer have what I had previously, which was a property, which would go and look up the value of the current to-do. I don't need that any longer because my view class is now passed an extra argument called context, which is the result of that route factory. My view can then store it on the view class and use it in the rest of the view. For example, in my edit form, I can refer to self.context to get the title of the current to-do. Previously, we did view.current or self.current to get at the title. Our code is simpler because of Pyramid's context pattern and support. But later, when we write tests, this is a much bigger deal. You don't need a database to test your view code. You can make a fake context and supply it when calling your views. Later, we'll show moving other queries out of the views. The templates can also use this change. For example, our view.jinja2 template is changed to use the context. When I'm showing the heading, I can say context.title. Like the request variable and the view variable, context is a first-class, top-level variable in all Pyramid template engines. You don't have to do extra work to pass it into the template from the response of the view. That is, in my view, I don't have to pass in context equals self.context. Back in our views, we can make a change in the way we use permissions to protect our views. Previously, views were only protected if we remember to put a permissions argument on the view config decorator. What if we accidentally overlooked this? Wouldn't it be better to secure all the views in one statement, then open up those particular views that need no permission? View defaults to the rescue. We decorate the view class as a whole with a view default. This is imported from pyramid.view. With this, we are saying by default, all views in this view class will have the permission of edit. Then we override those that need the view permission instead of this default edit permission. For example, the list view just needs a permission of view, whereas the add view, its view config no longer needs to state a permission. Why? Because we have a permission on the view class as a whole. One last cosmetic change. Let's change the site toolbar to show us the username we are logged in as to make it easier when switching between users. In our base template, we are going to add an LI. We're going to add a class to it. This is a bootstrap CSS class called navbar-text, and we're going to display the authenticated user ID. These sections on security cover a lot of ground. With all this in place, we can now show the running system. If I log in, I now show the username Jill that I logged in as. This came from the users model, sample data, Jill with the password of Jill1, Jack with the password of Jack2. These sections on security cover a lot of ground. Let's throw in some extra credit topics as we go along. Here's the first one. Usually we can say a view needs no permission just by leaving off the permission argument in the view config. But with view default, that's not possible. Or perhaps we want to make it clear we didn't forget about it, that a view explicitly has no permission. How can we do that? Imagine we are not logged in, try to add a to-do, and get a forbidden. I'll log out. I'll go to the to-dos, click add, and I'm forbidden. Let's open this up to allow anybody to add a to-do. Currently, my view classes protect all the views with an edit permission. This means you have to be a user that is allowed to edit. Let's block that by changing the permission to a built-in pyramid permission, and I will go to add, and I will say permission, restart, reload, and I'm allowed to do it. What we did in this case was say that forget the view default at the top. This view does not require any permission. Pyramid has a number of special permissions and special principles that can be used when constructing your access control lists. Pyramid's powerful, extensible, declarative, and mature security model really differentiates it from other Python web frameworks. In this section, we took a big step towards showing that power with resource-specific security and the context object. Our to-dos now have a to-do specific security model with declarative security statements on the class. This is already a huge win, but there's a lot more power and capability available. What if, for example, we could store an ACL on a particular to-do, having its security be different from all the other to-dos? In this section, we introduce object-level security. We will change the to-do schema to add a column for storing an ACL on the database row, convert our ACL handling into a dynamic method capable of returning that value from the database row, modify our initialize under DB script and sample data to store an ACL on one of the to-do rows. Finally, we'll introduce permission filtering of items. First, let's take a look at the completed system and see some of this in action. I'm at the top of the site, and I'm going to log in as an admin user. I'm going to take a look at the to-dos list. I see 3 to-dos, and I see the 2 buttons to operate on each to-do and the add button. Now, if I log out and log in as Jill, and I go to the to-dos, I only see 2 of the 3 to-dos, but I do see the buttons for those. If I log out and log in as Jack, I see 2 to-dos, but I don't see any buttons for managing either one of those to-do items. Let's jump right in. We said we needed to store ACLs on the to-dos, so that means a schema change in models.todos. Our class gets 3 changes: an ACL database column as an array for storing the value, a default value for ACL that will be used for the class or for instances that choose not to store a value and thus accept the default. A method under ACL under, this method, which returns the value from the database if there is one, or the default value if the row doesn't have a specific ACL. Self equals none. This is a weird bit of Python, so let's give an explanation. In the previous section on route factories, we discussed the difference between the to-dos /to-dos and /to-do/add routes versus the routes which need a specific to-do, such as /to-do/one/edit. On the former, we just returned the class. Those were about the collection. On the latter, we returned an instance of the class with the value in the database used. We have the same issue here. We need an under ACL method that can be used for the class as well as for an instance of the class. Same method. When the route factory returns the class, there will be no self value passed to the under ACL under method when it is invoked. Here. We thus have to give it a default value to allow it to be called without an argument when we're using the class instead of an instance. With that in place, returning an ACL attribute when it exists or the default when not becomes a simple one-liner. In this case, we look at self. If there's an ACL attribute, we use the getAttr to get it. Otherwise, we do a none. And if that doesn't pass, we return the default. Doing it this way is great. Most to-dos won't have a different ACL. It's an exceptional case. You can thus change your ACL in software without opening all the data and modifying all the rows. Let's change our sample to-do data to add a to-do with a custom ACL. Here are our sample to-dos. This is what the initialize under DB script uses. We have the same 2 that we had previously. We're adding a third to-do that is going to pass in not just the title, but it's actually going to assign an ACL for this particular to-do. An object level ACL. Another change in the sample data. We need an admin user in the model.users file. We add a third user, username admin, password admin3, and this user is going to be in a new group that we're going to call admins. Our initialize under DB script needs a small change. When we are creating each of the to-dos in our sample to-dos, we need to pass in not only the title, but we need to get the ACL from that sample data and pass it in to our model when it's writing to the database. These changes in schema and sample data mean we need to rerun the initialize under DB script. We'll show how that works. I'll stop my process and I will remove my database and I will rerun my initialize and pass it my configuration file. And so now I have my database with the tables created and the sample data pre-populating it. What does that ACL, this custom ACL that we added here, what does it look like in the database? Let's open PyCharm and look at that new to-do row. PyCharm's Database Explorer, and I'm going to browse my to-dos. And this is the value of the ACL. I'll move this out of the way so we can see the whole thing. And it is a string containing the JSON representation of the ACL. One more thing to cover. In our demo, we saw that some data and some buttons were not available based on which user was making the request. Admin saw all 3 of the to-dos and all the buttons. Jill saw 2 of the to-dos and all the buttons. Jack only saw 2 to-dos and no buttons. How did we do this? Pyramid can check permissions on routes, as we've seen, but also within the view for a route, you can check permissions on objects using Pyramid's request.hasUnderPermission method. Here's the documentation for the hasUnderPermission method. You pass it a permission, a string, and then an optional object, and then it tells you true or false on whether the current user has permission for that operation. We're using this in our list.jinja2 template to filter rows and buttons within a row if the user doesn't have the right permission. I'll go to my templates and I will go to list and take a look at the changes for this. Here I open my list group and then I do a for loop over all the to-dos. And before I start my list item, I do a Jinja2 if, a conditional. If this is true, then we will insert this item, meaning this to-do. The test we're doing is we're going to call the hasPermission method on the request and ask whether the current user has the view permission on the to-do that we are looping over. If so, we will draw all this. Next, to hide the buttons, because that's the view permission, the buttons are protected with the edit permission. We're going to wrap the button group with another Jinja2 conditional. If the current user has the edit permission on this to-do, then go ahead and show those 2 buttons. This helps make a good UI. We shouldn't show a button if clicking it will lead to a forbidden screen. Also, we shouldn't show the title of the to-do if the user doesn't have view permission. The title, in fact, might contain something sensitive. Let's give another try at some extra credit, this time around our ACLs. Here's our default ACL for the to-do object. It says 3 parts: allow, principal, and permission. If there is allow, does that imply there is a deny? Let's do a fun test. We'll view a to-do, then change the ACL in the database using PyCharm's Database Explorer. I'm logged in as the admin user, and I'm viewing the to-do that has the custom ACL on it. I'm going to go to PyCharm's Database Explorer, and I'm going to browse the table for to-dos, and I'm going to edit this custom ACL, and I'm going to change this to deny. Now, when I click reload, I see that I'm forbidden. That is because my ACL denies this statement rather than allows this statement. If you are in this group or you are this principal, then you are denied the view permission. Let me put it back the way it was, reload, and it works. We could instead operate on the class, which would then apply to the 2 to-dos which don't have an object level ACL in the ACL column of the database. Back in my code, I'm going to go to my to-dos model, and I'm going to add a deny at the class level for the Jill user on the view permission. So first I need to import deny, and I'm going to add a new statement, deny Jill the view permission. I will comment this out first and log in as Jill. And Jill sees the two to-dos. If I uncomment this, let the server reload my page, I'm forbidden because I don't have permission to go to the to-dos. However, if I modified this to put the deny after the allow, then it works. That's because it goes through each access control entry, ACE, in the access control list, ACL, finds the first one that matches. This ACE matches before it gets to the deny. Pyramid security can be very granular and dynamic. In this section, we looked at object-level security, in which we got ACLs from the database and combined them in rich ways with ACLs in the software. We have users in our database, but we can't do much with them in our web app. In this section, we add CRUD for users. That is, create, read, update, and delete. As we usually do, we'll start with the demo. I will log out and log in as the admin user. If I click on this new users link, I will see the listing of users. I can visit a user and see information about the user. I can add a user and see the user listed here. I can edit the user and see their name and go back to the list and see it here as well. And I can delete that user. Back to our code. First, let's do another form of housekeeping. We currently have our software organized by what kind of function it serves. Models are in one directory, templates in another, and views in a third. But when we're working on a site, we usually focus on sections of the site. For example, we want everything for to-dos in one place, for users in another place, and perhaps an area for the overall site. That lets us concentrate and focus. In this section, we've reorganized our code into topic-based subpackages. Under the project area, we have our software package with subdirectories for site, to-dos, and users. If I expand one of these directories, such as to-dos, I see I have an under init under.py to make it a Python package. I have my models, I have my views, and I have my templates that are all associated with the to-dos. One part didn't fit in, the SQLAlchemy custom column type for arrays. We could have stored it under site, but we decided to store it at the top level of our code. With this refactoring, to-dos contains the models, views, and templates for its part of the site. In making this change, though, our templates broke. As the base.jinja2 parent template, the file was no longer in the same directory with the other template files. Here's how we fixed it. Previously, we extended base.jinja2. Instead, we added a pyramid asset specification. This works because pyramid under Jinja2, the package integrating Jinja2 into pyramid, understands pyramid's asset specification. When Jinja2 requests a resource, this package, pyramid under Jinja2, steps in to resolve the path. As a note, pyramid under Jinja2 also has a way to register a number of directories to form a search path. We didn't choose this option, as explicit is better than implicit. On to users. We added some code to our models to get them plugged into the web app. Our user gained two attributes. First, since we are hooking users up to the web UI, we need a security model. In this step, we restrict looking at users to being an admin-only function by setting an ACL that only grants the view edit permissions to the group admins. Here you can see the ACL. We don't need an ACL column in the database, as we don't need object-level security. We also added a title property. This lets us conveniently display the first and last name together as one string. Next, and most important, we need a route factory. This is very similar to our previous route factory. First, it decides if the current URL points at the collection, /users or /user/add. If so, return the class. If not, get and return the specific user. we'll step through that. First, our route factory for users looks to see if there is a route parameter for ID. If not, we must be on the collection and just return the class, not an instance. If there is an ID parameter, convert it to an integer, do a query against the database to find it. If you found a user, return it. If not, raise a not found. Let's see how we put this route factory into the web app's configuration. Previously, we had our to-do routes with the route factory. Here we have our user routes with the route factory. Same idea, different dotted path. Let's take a look at the views for our users. Similar idea, we have a schema for the form. It just has more fields on it. And we set permissions at the view defaults level, then override it as necessary. In this case, we're going to say there's one security model just for admins. One final point. We added a link to users in the site toolbar. I will go to the site and I'll go to templates, base.jinja2, and show previously we showed to-dos in the toolbar. Now we also show users. And that's it. We have listable, editable users. Let's do some extra credit. First, we're currently logged in as the admin user. What if we went into the database and changed the admin user's password? For example, I'm opening the database in PyCharm's Database Explorer, and here are all the rows. If I edited the password here and then reloaded in the browser, it would still work. The admin user would still be logged in. This is because the security credentials assigned during login do not contain the password. This is a good thing. We don't want the password traveling between the browser and the client. Instead, a token is assigned as a browser cookie. This token lasts for a period of time that is configurable. At the next login, the admin user will have to supply the new password. One other extra credit. We discussed Pyramid under Jinja2 and its configurable search path for looking up templates. Here's the documentation for it. As you can see in the documentation, you can add to your configuration file a location to go add to the search path to also look for templates. Let's give that a try. For example, if I go to my to-dos list, this works fine. If I go and edit my to-dos template for list and change this to just say base and reload, I get an error. The error is a Jinja2 exception. It couldn't find the template based on Jinja2 in this search path. That's because our search path, we actually need it to go look in the site templates. So let's fix that. I'll go to my configuration file and follow the instructions as they explained here. Jinja2.directories equals, and then a path. This is a pyramid asset specification. When I save this configuration file, pserv automatically restarts the server. If I go back to this error, then it works again. We prefer explicit over implicit, so demonstration of this is just for illustration. In this section, we hooked users up to our UI and gave a basic security model. In the next sections, we introduced the concept of ownership, which also introduces database relationships. We now have users that can be viewed and managed with the browser and stored in a database. Let's put that to use by having a concept of to-do owners. That is, let's keep track of the user that created a to-do and provide links from to-dos to an owner and from a user back to their to-dos. In this section, we'll cover some important topics. Change the schema to maintain an owner relationship between to-dos and users. Set up that relationship to delete all to-dos when an owning user is deleted. Have the toolbar show the first and last name instead of the username and make it a link to a profile page showing user info. And finally, change the View To-Do page to provide a link to the owner's profile page. Lots of good stuff to cover, so let's start with the demonstration. I'm going to log in as the admin user with a password of admin3. I'm going to show adding a to-do. It shows up in the list of to-dos, but if I go to the profile, we see it linked under this user's owned to-dos. Back to the to-dos, I see that secure task is a to-do owned by Jill Smith. If I go to users and delete Jill Smith as a user, when I go back to the to-dos list, I see that the to-dos owned by Jill are no longer visible. Over to our code. Nothing changed in our setup.py or development.ini, Let's get started slowly by looking at a couple of housekeeping tasks. First, let's change our user-based routes to put the username in the URL instead of the user ID. This is more friendly to have /user/Jill instead of /user/1. Our under and net under needs the route parameter to change. In these cases, it's the ID. But for the user URLs, it's going to be the username. Our route factory, as shown on the routes, needs to get the context, that is the current user, by extracting this new parameter username. We'll go to the user model, and our route factory, user factory, will do that extraction and then return the user. One important point, username needs to uniquely identify a user since we're not using user ID anymore. Our schema, which had ID as a primary key, needs a user ID to be unique in that table. Finally, our template that lists the current users needs to provide username to request.route_URL. Let's open that template. And here, when we call route_URL, we're going to supply the username. As a second housekeeping task, let's move some of the database queries out of the views and into the models as class methods. We often get a sorted listing of items in that table, as well as get a single item. We currently do that in our views and route factories. Let's move it to the model class, starting with users. Here we have a class method by username, which can be passed a parameter of username, and then it will do a query against the session to return the first user with that username. And then the same for list, we're going to do a query and then sort it based on last name. As a note, in Python, the class method decorator lets us turn a function into a class method instead of an instance method. We can then call the method from the class, such as user.SumMethod, and not have the method accept self as the first argument. That is because there's no instance. Instead, we are passed the class itself as the first instance. We use this for our two helper methods as shown here. For the other side of this, we need to change our views in the list view to just return the list class method on the user class. Enough on the housekeeping, over to ownership. The core conceptual change is in the database models, so let's start there. We added two imports to get foreign key and relationship. These are put to use in connecting to-dos to users. We have an owner ID column, which has a foreign key to the users.id, and we have an owner column, which is a relationship to a row in the user table. Now, asking a to-do for its owner value will retrieve the user row from the users table, turn it into a Python instance of our registered user model, and return it. Let's see how it looks on the other side when hooked up. As we saw in the demo, we can go from a profile to the to-dos by following this column, which is a relationship to the to-do table. And the cascade says, as we saw in the demo, if you delete a user, then you delete the to-dos that belong with it. This ownership relationship is part of the core SQL data model, and SQLAlchemy provides a tremendous amount of infrastructure to make it performant, reliable, and useful. Our initialization script needs to be made ownership aware. As we add sample data, we now first add the user and then assign an owner during the process of adding to-dos. Of course, this means we'll have to delete our SQLite file and reinitialize the database. We can now put this to work. Our view to-do template can show the owner as a link to the profile page. This template now has a section about the owner that has a link to the user's view for the owner's username, and then we show two pieces of information about the owner. Let's take a look at how a user can show the to-dos registered with that user. The user object has the column to-dos, which is the relationship to the to-do table, and then we're going to iterate over each of those to-dos and provide a link to the to-do ID, also showing the to-do title. Adding a to-do gets a little richer. We need to record the currently logged in user as the owner of the to-do. In our view class, we need to get access to the user data in the database. We'll do so in the view constructor. With this, we get the row for the currently logged in user, making it available throughout the view class. Our add handler when making a new to-do, provides the current user as the owner. Good news, our delete view does not require any extra work, as the model's cascading delete does the work for us. As a last bit of work, we set up the site toolbar to show the logged in user's first and last name as a link to their profile page. As a note, we are getting the view.currentUnderUser in base.ginger2, which is used on all templated views, which means duplicated work to assign this in 3 view class constructors. In a later lesson, we'll show how to centralize this. We covered a lot, especially on using SQLAlchemy to configure database relationships, connecting to-dos and users along an owner relation. We'll put ownership to work in the next section with a security model based around owners. In our final section on pyramid security, we put the icing on the cake. We have users with passwords managed from a web browser and stored in a database. Users can be in groups with site-wide security on certain operations, as well as per-object custom security, all done in a declarative, configurable security policy by the framework. In this section, we take the idea of ownership, a user that is associated with a to-do, and extend that to the security model. The admin user can view and manage all users. A user can view and edit their own profile. Editors and everyone, not logged in, can do nothing. Let's see this ownership security model in a demo before seeing the implementation. In my browser, I will log in as admin, look at the to-dos, visit a to-do, and go to the owner. Now I will log out. I will log in. This time logging in as Jill. I will list the to-dos, go to a to-do, and then go to the owner. I'll go to Jill's profile and see the list of the to-dos. I'll click on users and get a message saying that Jill is forbidden to see that. Now if I log out, log in as Jack, if I click on the to-dos and view a to-do, and then click on the owner, I will get a forbidden. Jack is not allowed to look at Jill's profile. How did we accomplish that? Our content under/users now has a security model. Did we do this by assigning an ACL to each piece of content, granting the username for owner the rights to view? Nope. We instead used the dynamic nature of ACLs to allow a concept of owner in the security model. Let's start with users.models, where we define our model for each user. Our under ACL under is different. We previously had a class attribute. Now we have an instance method. Pyramid allows either attribute or Python at property for the ACL, or if it finds a callable, Pyramid will call it. We saw this also for the under ACL under on the to-do model. For this ACL, we first see if we are being invoked as a class method, meaning from the /users or /user/add URL, or as an instance method. If the former, class method, we return an ACL saying only admins can view and add users. If the latter, meaning we are looking at a user, we append to that admin-oriented ACL 2 ACEs, access control entries, giving self.username the view and edit permissions. We don't have to record on each instance a specific allow for a specific user, meaning we don't do it on the content in the database, we still do it in the software. This is very important. We can demonstrate this. In the browser, logged in as Jill Smith, I'll click on the profile link for Jill Smith. Everything works fine. I'll come back to this ACE and remove Jill from having view permission on the profile. Once I restart, I will get forbidden. Going back to the code and putting the ACE back, restart, reload, and I can see the profile again. This adds another powerful vector to an already powerful security model. Let's explore more by doing some extra credit. First, this ACL for users has 4 access control entries, ACEs. We allow admins 2 permissions, and then we allow owners 2 permissions. Can we combine these by making the permissions a sequence? Let's show this by collapsing these 2 statements into one. And then the same here. With these ACLs now edited, let's go and make sure that we can still do our editing and viewing. Why is that possible? Pyramid's documentation under elements of an ACL explains that the third element in an ACL can be a sequence. One last point. We have object-level ACLs in the database for a single to-do, but not for to-dos as a whole. This prevents, for example, allowing configuration of security via a web browser. Why? Well, because there isn't a database object representing the collection, and there isn't a way to have permissions start from a to-do, then keep looking for ACLs back up the URL hierarchy. What if there was? In fact, Pyramid supports this through something called the resource tree. This concludes our coverage of Pyramid security. In this section, we added a security model based around resource ownership. With the rise of HTML5 capable browsers, modern web development has pushed more of the web application out of the server and into the browser. Starting with ubiquitous helper libraries such as jQuery, and now with powerful, full-featured JavaScript MVC frameworks such as Angular and React. The state-of-the-art now involves writing server applications which receive and respond JSON. That is, they are UI-less, with the rendering happening in the browser. In this section, we'll take a simple look at JSON in a Pyramid application. We'll include jQuery into our page, then use it to help echo a message from the server. As our starting point, we'll go back to a minimal Pyramid application, then start rebuilding our to-do application step by step. First, we'll take a look at the result. In my browser, I have a web page with an input box. If I type in Bob and hit enter, I will be echoed back a message that says, "Hello, Bob." Not much to it, but a good starting point. Let's take a look at the code. A minimal setup.py with requirements that depend on Pyramid and Pyramid Jinja 2 and our normal entry point. Our requirements.txt is the same. Our development.ini configuration file, same. Our under and init under, which organizes our WSGI application, is also very basic. We import the configurator again and create an instance of the configurator. We include all the settings from the Pyramid under Jinja 2 add-on. We add a static view to this path for our JavaScript. We make a route for the root URL. We make a route to send and receive JSON, and then we create our app. Our views.py file has two views to handle, the home view and the greeting view. The home view serves up a templates/home.jinja2. The second view grabs a value passed in over JSON and returns a greeting based on that value. And here we see one of the first differences with previous sections. Earlier, we got incoming form data from request.params. This view gets the name value from something called request.jsonUnderBody. What's that about? Let's take a look at the Pyramid docs. Dealing with the JSON encoded request body explains the issue involved and gives an illustration of it in use. In a nutshell, we're no longer dealing with the strange world of HTML form encoded data. Instead, the browser sends JSON and receives JSON, with JavaScript mediating the communication. How do we return JSON from Pyramid? Note the renderer equal JSON. We previously used renderer when configuring a view to give the name of a template. For example, this view. Pyramid has a number of built-in renderers, including a JSON renderer. It is very simple to use. Just return some data, as we have with this dictionary, and Pyramid will encode that data as JSON, then set the correct HTTP response headers. Once you get used to just dealing with data, it will seem like the way it should have been all along. Over to our HTML and JavaScript. First, our template at home.jinja2 for this view. This is a very simple HTML file, which includes jQuery from a hosted site. It also loads a JavaScript file in our project using the same request.staticUnderURL function we saw in previous sections for loading CSS. This will get the static greeting.js file. The HTML provides an input with the ID of name and an output with an ID of greeting. The goal is when the user presses enter in this input, we send a JSON request to the server, get back a greeting, and update the page. Let's see how our JavaScript file does this. If you have experience with jQuery, this should look familiar. When the document is loaded and ready, we register an event handler on the input element's change event. Whenever that change event fires, we get the value, post it to greeting, then stuff the response into the paragraph value. We get the value, we send an AJAX post to the URL/greeting with the value, and when you get the response, you grab the greeting and assign its text value the response value. We do have two caveats though. As explained in the pyramid docs, for jQuery, you have to encode the data as JSON. In your browser's request, you have to set the content type to application/JSON so that Pyramid will accept the request and see that it is being handed JSON instead of form data. That's what we do in the AJAX settings dictionary. We JSON stringify the dictionary of data that we're going to send, and we tell that request HTTP headers to set a content type equal to this value. Doing so will trigger Pyramid's JSON underbody support. That was pretty straightforward, so let's take a crack at two extra credit questions. First, could we display the message from the server as the user typed instead of making them press enter? Piece of cake, actually, and all done in JavaScript. We want a different event to handle and register an event handler. Instead of change, we are going to make this be key up. I'll save that, come back to my page, hit reload, and as I type Bob, I get talked to from the server. Next, our Pyramid app had two routes, home and greeting. Could we collapse those into one route, as we saw in a previous session, with two views distinguished on get versus post? Sure, and in fact, that is a better way to do it. First, we will remove this route. We will go to our views, and we will change this to route name of home and add a request method equals post. And then finally, in our greeting, in our JavaScript function, change the URL. Instead of going to /greeting, another URL and another route, we're just going to go to /, and since we're sending post, it will trigger this second view instead of the first view. And as I type, I get the response. This section gets us set up for JSON in Pyramid. We saw how to get JSON input and input data using request.json underbody and render a response using the JSON renderer. With the JSON-based view in place, we see the basic outline of how we can move some of the UI out of the server and into the client. Let's take another step in this direction by doing the same interaction, this time with AngularJS, a JavaScript MVC. AngularJS, like React.js and other frameworks, is an ambitious attempt to create a full-featured client-side tool for interacting with the server using data. During the coming sections, we'll use AngularJS as an example of this trend, recreating much of the UI interactions we had in my site and its to-do list. In this section, we simply do the greeting again. Doing this in Angular introduces a number of concepts. First, we'll do a demonstration, and as a reminder of the entire development chain, we'll start again from the top. First, we get into our virtual environment. This prompt does not have the virtual environment. Next, we make sure we install all of our dependencies. And now we can run the server in reload mode. When I go over to my browser and reload, I see a little bit different site, the familiar Bootstrap look. Now, as I start typing, I see the result. Back to the code. In our code, nothing changed on the Python side. Our HTML and JavaScript, though, changed quite a bit. We'll start with our Jinja 2 template. Some of this should be familiar from our work with Bootstrap. We include the Bootstrap CSS, and we have a site toolbar as a nav element. However, switching to Angular means writing an Angular app. We include angular.js at the bottom, where we previously included jQuery. We have an element on the HTML tag, an attribute ng-app, naming our AngularJS app. And we have on the body something called ng-controller to define a controller for this page. Next, our input element that collects the value gains an attribute called ng-model, basically the name of the variable that's going to be changed, and then an event handler, ng-change, pointed to the function that will be called when this event fires. Finally, the output, this paragraph, uses Angular binding to point at a variable to display whenever that variable changes. Our greeting.js file is structured like a normal AngularJS app. First, we create a module app. This matches the name we used in the HTML elements attribute for ng-app. We register one controller, this home controller, that is in scope for this page. This controller roughly matches what we had previously for handling the information. Whenever the event is fired, whenever the change event is fired, the controller, and that name comes from binding the home controller in this space, in this scope as CTRL, its greeting method, getGreeting, gets called with this value. New name is the value from ng model. Passes in the new name. This is the function that was pointed at. It gets passed in the new name. It does an HTTP post to /greeting with this data. And when it gets a successful result, it takes the response, assigns the response.greeting value to the greeting on this controller scope, making control.greeting have a value. That's it, a basic Angular application, a good bit more ceremony than the jQuery version, which reflects the difference between a library and a framework. Let's put this to use in the coming sections as we build our to-do app using JavaScript MVC and Pyramid as a JSON server. One more step with our greeting demo. As you might have seen, we're not getting much value from Jinja 2. This makes sense, as the point of JavaScript MVC frameworks is to assemble the UI in the browser. Let's take that step and remove server-side HTML templating from Pyramid. This then starts the process of serving the UI components, HTML, JavaScript, and CSS, of our web app as pure static assets. Taken to the furthest extreme, the front end can be delivered from a different server, completely decoupled from the back end, or even back ends plural. Let's start with the demo. I'm going to the root of my website at /. I can also go to /index.html. We will see why both of these work the same in just a moment when we look at the code. I can type in Bob and see the same effect that we saw earlier. Now, over to the code. Our setup.py has changed because we no longer use Pyramid under Jinja 2. Also, our configuration file, development.ini, has a small change. We removed a setting at this location to turn on the reload templates for debugging. Our init_under.py has several differences. First, we're no longer doing a config.include from the Pyramid under Jinja 2 package. No more server-side generation of HTML. We have a route for the Ajax greeting at /greeting, which was the same as before. But then we have an odd section where we make the root URL under / into the static part of the site. We have basically turned Pyramid into a web application which serves static assets, CSS, images, JavaScript, Angular template files by default, except for routes we specifically configure to go to the views. And it's important for the static route to appear after the dynamic routes above it to let the views get the first chance at the URL. While content under / is served from the app directory on disk, the route for the exact URL of / is handled by this route, the app under HTML route. Why? Let's take a look at the views to see. Our index under view method is the view which handles the / route, app under HTML. Its name gives away its purpose. We don't want to make the user type http://localhost:6543/index.html. We'd like to omit the index.html part. Some web servers automatically handle this, but WSGI servers don't. This function is used to return the contents of the static file at app/index.html as shown in the view classes constructor. Here we construct the path of the file that we want to return, and then we return a Pyramid file response object pointed at that file. With this, the URLs / and /index.html are equivalent. Back in our views, the greeting view is unchanged. It receives some JSON data posted from Angular and returns a string response, same as we saw before. Let's take a look at the contents of our now front-end UI in the app directory. The index.html template is almost an exact translation from the Jinja 2 template. Remember, Pyramid is serving these files statically and not interpreting them at all. We've added a fave icon, which serves this PNG file, and we removed the server-side generation of the root URL. Previously, this had Jinja 2 code in to insert request.route under URL. Our Angular code in greeting.js is the same, but let's explain a bit more about how it works. When the user clicks the button, the template calls the getGreeting function on the controller, this function. That function then calls Angular's http.post, which returns what is known as a promise. A promise is a callable which runs asynchronously. And then when the background work is done, it performs some code that you hand to the promise. We're handing this function to the promise to be executed in the future when this asynchronous request succeeds. This function that we're handing says to store the result data on an attribute of the controller, control.greeting. As soon as this value is updated, Angular updates the screen because our template was bound to this data using Angular's ngbind. In this section, we've taken a big step forward towards modern-style browser-based web applications. Our UI is rendered in the browser now instead of on the server. We removed server-side templating from Jinja 2 from our Pyramid application and set up and configured our Pyramid routes to serve static assets by default. We've now moved our UI outside of Pyramid by sending an Angular template to the browser for rendering. At the moment, though, we're not yet doing REST, which is an architectural model about listing, adding, viewing, editing, and deleting resources on the web. We're simply sending a string to the server and getting a string back. In this section, we reorganize our front end in Angular and our back end in Pyramid around the concept of REST resources. Let's take a look first at the demo. We have our home page as before, but our header now has a link to a part of the site for to-dos. Clicking on that link takes us to another URL on the server, todos.html, which fetches another HTML page. This HTML page has JavaScript code in it, which asks the server for a list of to-dos, then the JavaScript code renders HTML list items for those to-dos. We've made a number of changes in our code. Let's first look at our init_.py. Only one change here. Instead of a URL of /greeting going to a route for greeting, we have a URL of /API/todos mapping to a to-dos list route. As we build more of our REST interface, we'll have more URLs that make up part of a data web API. It is common to prefix the URLs for your REST API with /API. A few changes also in our views.py. First, we changed our view class to be named for the REST API that we're working on, to-dos. In this case, the to-dos REST API models the interactions between the front end and the back end. At the moment, though, it only has one API method, the one for getting a list of to-do items. Because our view class is now focused on a REST resource, the view for returning index.html as a shorthand at the /URL doesn't really fit in the view class. It's not really associated with to-dos. We thus moved it to its own standalone function and registered it as a view. Doing so really helps the view class look focused on its task. This view class now works on receiving and returning JSON, which means every view in the view class is going to have a renderer=JSON view predicate. Wouldn't it be nice if we could just make the statement once? We do so in a view_defaults registered as a decorator for the view class as a whole. And therefore, our view here doesn't have to say renderer=JSON. And finally, we put in some sample data to return when the to-dos list endpoint is called. Our templates have some changes. First, in index.html, the major change here is the addition of another script at the bottom. Angular-resource is an Angular module that makes it convenient and productive to model server-side REST APIs in the front end. We'll be introducing it in this section, then putting it to more use later on. This page does have a controller on the body, but it is just a stub and isn't yet used. Our todos.html page, though, introduces our first real browser-side rendering. We have an li tag with an ngRepeat attribute to list over the current to-do item data. For each of the to-dos on the controller, a to-do object is created and available in the loop, just like in Jinja 2's for loops. Each to-do creates an li node containing an anchor node holding the title and a placeholder for the link URL. The to-do title using Angular's template delimiter, and a placeholder because we're not really navigating to the to-do yet. That's our templates. Let's take a look at our Angular code now in a module called app.js. Several significant changes. First, our app module now has a dependency on ngResource. This is the module we loaded with the other script tag in the HTML. We also declare controllers for each of the two pages, but we also create a factory. In Angular, factories are a way for a controller to have outside code injected into the controller to perform work. We don't want the controller to have miles of spaghetti code. Instead, we put the service-oriented code into a factory, then call that from the controller. Our factory is suspiciously simple. The reason is that it lets ngResource do most of the work. That one line, return resource, wraps a bunch of work. In this case, it means our controller can simply call ngResource's built-in .query method and get a promise. Here's our controller. We are passed in the factory. You can call that method and get the to-dos. When this promise is resolved, this function, the query, returns a promise, meaning the HTTP request has been sent and Pyramid has returned a response. Angular will update this .todos value. Our template will then have new data and redraw itself. One more fun demo. PyCharm has a helpful REST client tool in the IDE, which helps discover and debug what's going on in your backend. Let's take a look at this in action. In PyCharm's menu, I'll go to Tools, Test RESTful Web Service, and I'll put in the URL and then the path. And now if I click the Go button, I will see the result from the server. While there wasn't much new code in this section, we took another big step forward by introducing to-dos as a REST API in our backend. We then changed our front end to consume REST endpoints and update the UI. We have two HTML pages acting as a REST front end, but that's not really the style of modern JavaScript MVC frameworks, which act as single-page applications. That is, you make one request for a traditional HTML file on the web server. Then after that, you don't reload the entire browser page between clicks. You use JavaScript to update parts of the screen. In fact, you can see that approach in earlier sections. In Jinja 2, we started by repeating a bunch of boilerplate HTML on every template. We then introduced Jinja 2 template inheritance with one main HTML file, which other views plugged into. Let's start by looking at a demo. The first thing to notice is that by clicking on the root URL, we were taken to a URL ending in /#/. We can show it again by manually changing the URL, removing the #/. Again, we're redirected to this part. With Angular's default approach to single-page applications, different pages or routes are connoted after the hashtag, which prevents the browser from reloading the page. The second thing to notice is that clicking on to-dos has a lot faster update. That's because we're not reloading the entire page and environment. All of our initial JavaScript and CSS is already loaded. Let's take a look at the code. First, there are no changes to setup.py, requirements.txt, development.ini, nor _init_py, or even views.py. This makes sense. We've moved the UI out from the front end. Since this section doesn't change the REST API endpoints, the pyramid part is unchanged. We'll start with our server-side index.html file. First, our script tags at the bottom are different. We've changed from loading our external resources via a CDN to loading local copies. This helps with friendly editors such as PyCharm, who helpfully give us autocomplete and error warnings. We also, though, added a new Angular module with angular-route.js. This gives us, client-side, the same ways to map URL patterns to code and templates that we have in Pyramid. That's just the start of big changes in this template. It's the only thing loaded from the server. So like Jinja 2 template inheritance, it needs a slot that individual routes can fill. The div ng-view handles that. Each route results in that element, that div, getting filled with new HTML. Next, our nav element now uses URLs starting with the #/ prefix, for example here. Finally, we no longer have an Angular controller on the body. That is because controllers are now associated with routes. What do routes look like in Angular? Let's take a look at our app.js and see. Very similar with a second module dependency on ng-route, but we have added a module config function called here and defined here, which is run when Angular is starting the app, courtesy of the config line at the bottom. We tell this module config function to ask for the route management code, the route provider, then register 2 routes. The first route handles the home page, assigning a template and controller to the /URL, the template, the controller. The second route does the same for the /todos URL. Our controllers haven't changed, but what do each of these route templates look like? Let's take a look at home.html. This is an Angular template. Pretty simple. The to-do list.html. A little bit more code. We have the ng repeat. In this section, we changed the front end to act as a single page application with Angular routes. We're now ready to do a full REST API in Pyramid. We now have a single page application. In this section, we add back in missing features from our to-do application. That is, we add more REST endpoints in the back end and more routes in the front end for add, view, edit, delete of to-dos. Managing these in a database will be added back in the next section. As is our custom, we'll start with a demo. You see the home page. We can click on to-dos. We get a listing of to-dos. Now with an add button, we see the view of a to-do. We can go back and see that it has been added. We can click to go to it. We can edit it, and we can delete it. For the code, let's start with Pyramid. Our init_under_.py has some new routes. We see a single route for to-dos, plural, at /API/to-dos, and a single route for to-do, singular. How is that going to be enough? We have list, add, view, edit, and delete operations. As it turns out, they each use a different combination of HTTP verbs, allowing us to register different views for just 2 route names, thanks to Pyramid's view predicates. We also take a page from earlier sections and register a factory for the to-do route to allow loading the data for a to-do to happen outside of our views. Over to our views.py. Here we see our route factory discussed a moment ago. As in previous sections, it grabs the identifier from the URL, looks up a to-do, and returns it. Our view class has a new view for adding to-dos. It uses the to-dos route, but is called when an HTTP post is sent. Here is our add. Here is the view predicate that is focused on post. This is what Angular's ng resource uses when creating new resources, an HTTP post, as we will see. When this view is handed JSON data, it makes up an identifier and stores the to-do, then returns the data from the just stored to-do. This lets the front end know the identifier that the back end created for the newly added to-do. The other views are relatively simple. The to-do view returns the context, which is the to-do item looked up by the route factory. Let's take a look at that. It returns self.context, and the to-do factory as the route factory is responsible for returning that and then passing it into the view. The to-do under edit view stores the incoming title value on the current, that is context, to-do. We get the title from the JSON body, we store it on the context in the dictionary key of title, and then we return the context. The to-do under delete is even simpler than the earlier non-REST version. as it doesn't have to return a redirect via a pyramid HTTP found response. That's it for the Python side. In our static files, the initial index.html, we pull a trick to update the HTML title tag on route changes. Let's go take a look at that. Here's the title tag, and as we switch routes, we want to switch the value of that. We do this by making a small Angular service that individual route controllers can update with the page title. Let's take a look at how that controller would do that in app.js. For example, the home controller, which is responsible for the home page, asks for a title service and sets the page title to home so it will show in the title tag. Here is the title service. It's very small. Each controller can ask for it and then call the method to set the title. Our config function has new routes for each of the REST operations: add, ID edit. In particular, note the use of :id. Just like Pyramid's route parameters, Angular also has route parameters to extract variables from patterns in the URL. Let's take a look at one of these route templates in action. In the to-dos list, we have an add button at the top, and then we have buttons on each item. For example, the edit button goes to this route and hands the value for the route parameter. The delete button goes to the delete route and passes the entire to-do. Let's follow the path of the delete button's call to the delete function. Our to-dos controller, which is used on that template, has a function delete, which is called when you click the button and is passed a to-do. This is the to-do that is the actual ng resource object for that to-do item. This instance of ng resource has a $delete operation. Calling it will do an HTTP delete to the URL for that to-do and return a promise. Here is the function that we can call at the return of the promise. We tell that promise that when it is fulfilled by the server's response, we want to ask the server for an updated list of to-dos. There are more optimal ways to do this to avoid refreshing and redrawing the list. Let's take a look at the controller for editing a to-do. This controller asks the ng resource factory to HTTP get the URL for this ID. We do that right here. Then store the result on the controller's to-do attribute. We also define a function that can be called from the form to update the server with the new content, then change routes after successfully editing. This is called when you're submitting the edit form, and it does an update with the value of the to-do. And when Pyramid responds, we're going to use the route functions, $location, to change our URL to view the newly edited to-do item. The form is quite simple. The control.todo object is the to-do value stored on the controller. We insert the ID in the header. We then make a form which, when submitted, either by pressing enter in a field or clicking the submit button, calls the update function on the controller. We see that here. Our form inputs use ng model to bind the value typed into the form field to the underlying model. We did quite a lot in this step, but we've arrived at a functional CRUD, create, read, update, delete, to-do application. All we need to do is store the data in the database. That will be the topic of our next section. Our single-page application front end is complete, but our back end just uses dummy data. Let's put what we learned from earlier sessions to use and bring back database support. This session introduces no new concepts, so we won't start with a demo. Let's look at the code starting with setup.py. You can see that we brought back pyramid under SQLAlchemy and pyramid under TM as dependencies. Also, we added back the entry point for a console script to initialize the database. Next, the development.ini configuration file. Our configuration file brings back the pyramid.includes statement to call configure.include on pyramid.tm. As a reminder, the configuration include tells the pyramid add-on to run some initialization on the configurator, rather than you having to configure the add-on in your code. This is usually done in your under init under, but for add-ons that are optional to your software's basic use, you can do it in your .ini configuration file. We also define the connection string information used by SQLAlchemy. We next see some routine changes in the init under_under.py file. Our bootstrapping function includes pyramid under SQLAlchemy and registers our models with the SQLAlchemy metadata service. We also moved our route factory out of the views file and into a models file, which makes sense as its job is to retrieve a model from the database for the context object assigned to a request. Let's take a look at that models file. Everything is the same as in earlier sessions, with one change. Our model class gained a method called JSON under. In Pyramid, if your view returns an object to a JSON view renderer, this method is called to serialize an object to JSON. That is the object's JSON under method. Without it, Pyramid and Python wouldn't know how to convert a SQLAlchemy row to JSON. We also see at the bottom our factory function. Our views.py module has gotten quite boring, thankfully. We have to import some of our database code at the top, the session object in the to-do model. After that, our views are very similar to how our previous Jinja 2-based to-do views looked. They get incoming data from the request JSON body and update the context object. The context object in this case is a SQLAlchemy row. In the previous session, it was dummy data in memory. As the response is delivered, the pyramid under TM transaction manager takes all the changes and commits the transaction. Let's see this in action by starting from the beginning on our development sandbox setup. First, we get into a virtual env. Then we install our software. Let's initialize our database. And now we can run our server. When we go over to our browser, go to to-dos. When I add a to-do, this will be saved. Go back, I see the listing. I can stop the server, restart the server, go back, look at my listings, and we can see it actually was saved in the database instead of just being in memory. Since much of this was previously shown, let's do some extra credit. For example, it would be great if our view code didn't know anything about databases. We could then write tests of our views very easily. Let's see if we can get the SQLAlchemy session object, this object, out of our view code. We'll start in our init under_under.py and make a context object available on the first route. This is the route that handles listing to-dos and adding to-dos, meaning they aren't bound to a context object that is in the database. Next, over in our models file, we want to change our route factory, as we did in previous examples, to test whether the current route is for listing and adding, meaning the class, or view, edit, delete, meaning an instance. I will start with getting the value of the to-do ID from the route. If that is none, then we must be in the class. Otherwise, the to-do that we will return, instead of returning the class to-do, we will return the instance to-do. Next, we're going to add some class methods to our to-do class to help us with the functions the session was doing for us. We're going to ask the session to add a to-do with title equal title. This is essentially the code from our view that we're moving over here. And then finally, for delete, we'll tell the session to delete the passed in to-do item. Correct this mistake down here. In our views.py code, I can simplify things. My add can simply get the to-do from the context, which is now the class, and add, call the add method, the class method, passing in the title, and that calls this method, passing in the title, performs this work and returns the new to-do, which we then return. Next, my delete, we want to get rid of the session, so instead we can say to-do.delete, which now makes it possible for us to get rid of this. Let's take a look, see how we did. Go back to the code, see if I could still get my listing, see if I could still add, see if I can then delete that, and I can. Why don't we go, though, one step further? We've gotten the database machinery out of our views. Can we go further and have a route factory which grabs a relevant model object and passes it into the view as the context? Well, we already have that. But can we get rid of the to-do object being imported in our views? Because the context is handling that for us. Can we make our views not even have to know about the code in the model? So let's take a look at the first location of to-do. Here we have to-do.list. This can just be replaced with self.context.list. Why is that? Because our class method list does the work for us, and it is bound as the context, so we can just call that. Our other case of using to-do is here, just a little bit trickier. We can't use self.context to delete itself. We need to get the class for self.context and call the class method and pass in the instance. Now at this point, we've gotten rid of the to-do model as well. Let's see if this still works. Yes, listing still worked and deleting still worked. And there we have it, a view layer that really is solely focused on mediating the communication with the outside world. Our model layer starts to match the endpoint API, mediating access to the underlying storage. Of course, this is a matter of taste. Some may find that mimicking the operations both in the view and the model is redundant. But particularly if you do test-oriented development, having your views be testable without mocking a database storage is a big win. If the redundancy is too much, it's easy to write a base class which automates those extra methods. In this session, we took the final step towards catching up to previous work by bringing back our database as the storage for our REST endpoints. With this JavaScript MVC approach, you move the front end out of the back end and let the browser talk JSON data to REST endpoints. At this point, we've nearly achieved this. After getting the first HTML file, the browser never retrieves another full page. It's a single-page application. One last step, though. We haven't moved delivery of the UI out of Pyramid. We still serve up the initial HTML, CSS, PNG, JavaScript, and Angular files as static assets. In this step, we use a standard called CORS, Cross-Origin Resource Sharing, to have the front end delivered from a regular web server running in a different location from the Pyramid backend. Before we do that, though, let's take a look at a change that we hinted at in the extra credit of the previous session. Our model gained methods that did the basic REST operations, list, add, view, edit, delete, as well as encoding the responses into JSON. Rather than repeat that code across all our models, we hinted at the idea of setting a base class to mix in to perform that work. Let's take a look at that. We've added a new file, base_model.py, and it's a class with some class methods on it to do some of the operations, finding an item by ID, listing all of the to-dos, all of the objects, adding a new one, deleting one, and converting to JSON. With this, our model, the to-do class, is really just the schema now. We also subclass from base model, picking up those extra operations. There are a number of ways to achieve this in Python, and a mix-in class might not be the most pure, but it serves as an illustration on how we can simplify our work. On to CORS. The Pyramid community has an add-on that can help. Let's install it. We'll make it a dependency in our setup.py because after these changes, we will no longer serve the static assets from Pyramid. Take a look at our setup.py, and we're going to add this add-on, WSGI-CORS, as a dependency. Since we changed our setup.py, don't forget you have to rerun pip install-e.-r requirements.txt. This WSGI-CORS add-on helps because it makes CORS handling into a configuration-driven approach. With CORS, the browser requests and server responses set up extra headers for each side to allow each other to do certain operations across domains while preventing other domains from doing the operations. Pyramid has great hooks for centralized processing of requests and responses. WSGI-CORS, the add-on, uses those hooks to do all the CORS work for us based on our configuration. Let's next do that configuration in our development.ini file. We've made a number of changes to our bootstrapping to introduce a WSGI middleware filter. WSGI middleware are small framework-agnostic packages which can combine in processing chains before WSGI applications. Our pipeline section of our configuration file, assembles that chain, and our filter cores section configures the WSGI cores add-on with the cores policy we want on our site. In a nutshell, we allow a front end served from a local web server running on port 80 to issue requests across domains. And with that in place, our next backend change is nothing. The REST endpoints in our backend will now serve requests from a front-end URL served from localhost port 80. We do have to make one small change, though, in our JavaScript, telling it the full URL to the backend endpoint. Our to-do factory in the Angular ng resource is going to point, instead of a relative URL, it's going to be an absolute URL. Let's take a look at this in action. We're running directly to Pyramid because we haven't removed all the static stuff yet, but we can also use a web server to go to the application, and then when I list the to-dos, I'm going to port 6543, the Pyramid backend, using cores. In this section, we moved our front end out of our back end by configuring core support on our Pyramid server. With this, you can think of your Pyramid application as microservices consumed by a fast-changing UI developed independently of the back end. For example, the app directory in this section can be moved out of this My Site package and out of Python completely and hosted somewhere else. Our sessions so far have focused on application development with Pyramid and all of Pyramid's great facilities. But Pyramid is also known for something a bit more advanced, being a framework. That is, Pyramid's extensibility facilities let you build your own custom, built-for-purpose framework. The coming sections will show some of these facilities, why you would need them, and how to use them. In this section, we'll start with using the configurators include facility to build modular, reusable subpackages. We've been the consumer of this already, using config.include to bring in the Pyramid under Jinja 2 package and have it wire up its own configuration. Let's show the other side of this, providing the code that gets wired up. We're going to use the static under assets section as the starting point. We're going to refactor it to have to-dos as a separate component that can be included into a site. Here you see the contents of the static assets section. In these sections on extensibility, we'll be doing live coding. First up, we get our development environment set up in the same way as in previous sections. First, I need to get into a virtual environment, and then I need to do my pip install, but first I'll confirm that I have the correct pip. Yes, I am in my virtual environment, and my prompt changed. So I'll do pip install -e dot to make it editable, and -r requirements to do the requirements file. So we're set up. We're going to have a subpackage called to-do, so let's make a subdirectory with an init_.py to turn that to-do subdirectory into a Python package. This file will have a single function named include_me, which is past the configurator, and then adds the routes for the to-do package. Let's do the function. And what I'll do is open up the previous routes and cut them from there and put them in the under_init for my to-do package. The name include_me for the function name is a special part of the Pyramid configuration protocol as explained in the docs. Here's the chapter on Pyramid configuration, and include talks about having a separate callable that can be included by pointing at it. You don't have to call it include_me, but if you do call it include_me, you can just leave it out of the path that you supplied to include. So with this include functionality, you can define a function in your subpackage, this include_me function, which is in my to-do subpackage, to do configuration for that subpackage to do. During startup, when the parent package includes your subpackage, it passes the configurator instance into this function. Thanks to this, sites using your add-on, your to-do add-on, don't have to manually wire up your subpackage, meaning they don't have to add all these routes. We can then move the to-do oriented views out of our MySiteView class, which is in here, this class. We can move all of these to-do oriented views out and into a views.py for this to-do subpackage. So in to-do, I will make a new file, views.py. For now, I will just copy this entire file, paste, then start removing the parts that aren't needed. I'm going to call this to do, and I'm going to not need the home view because it stays with the site. And we'll check and see all the imports are still there. The original can get a lot smaller. This is the views.py for the site, the web app that will be including the to-do subpackage. We're going to delete all of these views since they're all about to-dos, which means we will not need these imports, nor will we need the not view config file, and we're not going to need these sample to-dos. The templates associated with the to-do views get moved over as well. I'm going to make a subdirectory, templates. I'm going to take these templates, add, edit, list, not found, and view. I'm going to move them to the templates directory, and I'm not going to search for references, tell PyCharm not to help me so much. We do need to make a change in these templates to have the view templates correctly refer to the base template. So for example, and I'll close some of these tabs, in the add template, it says base.jinja2 no longer in the current directory. So I need to say up, up, and up to get to it. I'll copy that, edit each one of these. Also, we make a couple of changes to the under init under.py in our main site. I'll close these templates. In this one, and I'll collapse the to-do so we can make sure we're pointing at the correct one, I removed all the other routes, but I still need to include the include me from the to-do application. So I will put this in here, and I'll say the to-do application config.include the to-do. It's not a formal Python package now, so I will use relative reference, relative import, and I will say config.scan of the package. I'll make a note to myself that this is my site. With this in place, we should be able to run pserv and see the results. All right, we have a conflict error in our configuration, and this actually makes sense, and it shows some of the help that Pyramid can give with configuration. If you make a mistake, it will tell you, rather than just doing something dynamically at runtime. In this case, we did a scan of everything under here, and we'd already scanned to-dos. So if I say .views and say only scan in the views file in the my site package, then we're back to being in good shape. Let's take a look at our refactored site to make sure that it still works correctly. In the site view, home, now I'm going to go to to-dos, and I get an unhandled exception. We'll take a look. It says a very useful error message. Hopefully you can spot the mistake right there. I went up to the correct directory, but I forgot to put templates/template/base.jinja2. Pretty easy fix. I will do that for each of the files. And then the final one. Now, when I reload, I get my to-dos and each of the particular views. Let's do a couple of extra credit items. First, it's a bit of a pain making the subpackage know the path to the base template. In fact, we just demonstrated that, part of the reason for leaving that error in there. What if it is used in a parent package that puts the base template in a different directory? The Pyramid under Jinja2 add-on provides a way to specify in the parent site package the directories that templates might be in. You specify this in configuration. Let's see this in action. First, let's put that configuration setting in the site packages development.ini configuration file. Here's the file. Here's what the setting looks like. jinja2.directories equals, and then I'm going to put the correct asset specification, Pyramid asset specification, for a directory containing templates that should be available to anything in this process, whether it's in the main package or in the sub package. Now, once again, we edit all our templates. This time we make things simpler. We don't have to provide the path. Base.jinja2 is in a well-known location due to that configuration setting that we put in. Does this still work? It sure does. Of course, we still have a tight coupling, the name base.jinja2 and the names of the blocks we were filling, but that's a different topic. Next, what if I include a package that uses a part of the URL space that collides with my site or another package? The parent my site package has lost control over the URL space. Let's fix this with a cool pyramid feature to let the calling package, my site, put a prefix on all the route URLs generated when used in my site. So I'm going to go back to the under init for the outer, and I'm going to change this where I include my add-on to also say I'm passing in a prefix. Now in our to-do packages under init, I can remove this prefix and let the calling package be in charge of it. So now when I mouse over and go to it, I see site to do is the prefix instead of to-dos for all of these URLs. One final point to add. We didn't do the work to move to-do, the subpackage, into a completely different Python distribution with its own setup.py, as that's too much to show in this simple illustration of include me. That is, though, the way you would do it for pyramid add-ons that can be used in lots of different sites and distributed. Still, even when you are building an internal app, breaking your project into sub-projects is attractive. In this section, we showed how you can reorganize your project into sub-packages that are included into your main site via the include me function. We have a modular code base now, a mostly reusable to-do pyramid add-on, albeit without a separate Python package, and a My Site web app which uses it. Let's put this to use and make our to-do pyramid add-on configuration-driven by adding a configuration setting for the name of the base template. We'll begin with the result of the includes section, including, no pun intended, the extra credit items. Let's start with the place that uses this setting, our to-do add-ons view code. Here's my views for the to-do, and I'm going to add in this location. First, I'm going to grab the settings, which is a default pyramid facility hanging off the registry, a way to get at your configuration settings. And I'm going to assign the base template from the settings. I'm going to say get the setting with this name. And if you don't find that, just use this as the default. Our templates can now refer to this setting. Let's edit each of them and replace the value used for the Jinja2 extents. So here, instead of a string literal, I will refer to that value that we assigned. I'll copy that, put it on the rest, and now we are letting the configuration drive the location of our base template. Now that our add-on is expecting it, let's have the calling package set it. We open our configuration file, and I'm going to add that setting that we were just looking for. And there we have it, reusable add-ons that can have settings in a configuration file apart from code, thus reusable in multiple sites. We can run our My Site web app and confirm. I'll run pserv again, go to my site, and when I click on to-dos, I get my listing. We have only scratched the surface on what can be done with extensibility by means of configuration settings. In this section, we set a value in our configuration file, grabbed it in our view code, then had our templates get that setting from the view. In the last step, our views retrieved a setting from a configuration file and made the setting available in templates. This is still repetitive though. Each of our views has to remember to do so. As we do more of this, our views repeat lots of code. In this section, we go a step further and centralize this as a custom method on the request. Pyramid has a powerful facility to let you inject new values onto the request unique to your add-on or site purely through configuration. You don't have to fork the built-in request object. We'll use the previous section, settings, as our starting point. I'm already in my virtual environment with a local editable package. First, let's take a look at the custom method. We'll put it in to-do under init under.py. That's in this file. The pyramid docs give a good example of how to extend pyramid's request object with a custom method. Let's take a look at those docs. Adding methods or properties to the request object. We're going to be using a property. So in this case, I define some functions which are passed in some information, and then I add an extra method to the request via the configurator. We'll first add the function with the logic for this request method. I'll make a function base template. It's going to be past the request, and I will copy this same from here and actually delete it because I'm not going to be using it again. I'll put it here, re-indent, give myself a little bit of spacing. Don't say self. And instead of assigning it, I can just return it. In the include me, I need to do one more step. I need to add a request method of the function above, and I'm going to put reify equal true to turn it into a property. Now, anywhere that we have a request object, we now have a base template property on the request. It's a property instead of a method because we passed in reify equal true to the add request method. Without that, we would have had to call it as a method. If we passed in property equals true, it would be a pure Python property recomputed every time it was used across the course of a request. By using reify, Pyramid computes it the first time and then returns a cached value on any subsequent usages during that request. With this, each of the templates in our add-on can use this in their Jinja 2 extends. I'm just going to get base under template, the property that I just defined by extending request, and I'm going to do that on the rest of them. No need to grab this value from the setting inside each view. This approach is very useful for a number of code-base-wide needs, such as a custom template API for your designers, or a particular way of setting up your SQLAlchemy sessions. We can show this in action. I'm going to run pserv again, going to go back to my site, and I'm going to go to the to-dos. We can make sure that it's obvious that this is actually being used. I'll just put a print statement in there, go to a to-do, and I see my print statement. Next, let's see how we would use this as a template API as discussed above. That is a namespace readily available in the templates, which has a number of project-specific properties and methods needed across most templates. We'll do this as a class with one of potentially many methods whose instance would be stored as request.todoAPI. Here I've typed in most of this class. It has a constructor that stores a request. I'm going to do a property called base template. Same thing as before, get the settings and return the particular setting. So we're in good shape. We just need to change the include me to get the to-do API. Now we can go back and look at our templates and change this to say to-do API as our template API for the to-do add-on. And with this, we don't have to register so many request methods and everything is well organized. And everything works as expected. In this section, we showed how Pyramid's extensibility can be used to register custom methods on the built-in request object. Our to-do add-on now has configuration-driven settings. Let's take a look at a really cool Pyramid feature, overrides. As shown here in the documentation, Pyramid lets your web app override views in your add-on without forking the add-on. See a little bit of an explanation with some examples of a view which can be overridden with a new view, and we can also override routes and assets. Again, the add-on is being overridden without forking. In this section, we'll replace the to-do list view with a custom view defined in our site. This view will sort the to-do items and then use a different template. We'll use request under methods as the starting point. First up, the new view in mysite.views. So I'll open mysite.views. Let's take a look at the view that we're going to be overriding. And here it is, the list view. I'll just copy this to give us a better starting point. And I'm going to do it as a standalone function since it isn't really related to the other views in this view class. It's going to be passed in the request, which means we can take off self. Need to import from .todo.views, import sample to-dos. And then what I want to do is sort these to-do items using the standard Python sort machinery. So I'm going to say to-dos equals sorted, which returns a new sorted sequence. Is sample.todos values. And for the key to sort on, I'm going to give a lambda expression and say sort on the ID. And here I'm going to replace this with to-dos. All right, with all this set up, we have a new view. Do we need to register it anywhere? Well, let's go take a look at our under init under for the to-do. Okay, here we go for the site. We have a section where we wire up the to-do application, then we wire up our site. I don't need to add a view or do another scan because that new view here is a decorator that is in .views. So when I run pserv, this should just work, except it won't because we'll have a conflicting configuration definition. So we get a good error message, configuration conflict error on to-dos under list. And that's because of the way that we have wired up our views in our add-on. We're scanning for decorators instead of using imperative.addView. Here in the to-do views, we're using a decorator for view config. If instead in our include me, we did config.add under view, we wouldn't have that problem. But instead of doing that work, we'll just use a feature of the pyramid configuration. I can say config.commit, and it will take all the configuration actions that it has currently queued up and go ahead and commit them, and then process the next actions, which will do the override. So with that in place, my pserv will now run. I go to my site, click on to-dos. I see I have an error. Let's go take a look at that error message. Obvious little typo. It's not .value, it's .values for Python to get the values from a dictionary. So I do that, restarts, reload, and I don't have the correct path to my template. I'm pointed to a templates/list.jinja2. It's looking in this templates, no list.jinja2. No problem. I can use Pyramid's fantastic asset specification to say my site.todo templates. And now I get the view with the items sorted. You see this is to-do number 1, and this is to-do number 2, sorted on ID. As an extra credit, let's see if we can override just a template instead of the entire view so that we don't have to recreate the logic. We just want to change the preparation. So for example, we want to provide a different template for the to-do view. Instead of to-do templates view.jinja2, we're going to use our own template. So let's start instead by going back to our code, going into to-do templates view. I'm going to copy this to my site, templates. I'm going to put something in here that says overridden, and I'll leave the base template where it is. Close some of these. And in my under init, here I want to override a static asset. Let's go back to the docs. The docs talk about overriding assets, and you use this kind of statement, config.override under asset. Here we have config.override asset, the item that we want to override, and the path of the thing that we want to override. This is in the mysite::to-do subpackage, templates view.jinja2 is a file. Replace it with the view.jinja2 that is directly in the templates directory of my site. So my site templates view.jinja2 is going to have the word overridden in it. When we come over to the browser and reload, we won't get that. We don't see the word overridden. And that's because we are overriding a full asset specification here, but the original view defined the renderer without the asset specification. We replace it to be like that, let it restart, hit reload, and you get overridden. As one more extra credit, could we remove the need for the .commit? That was a little bit of an edge case that seemed kind of weird. Why do we need to do that? Well, if we go into the to-do add-ons under init, and we take a look at adding all the routes, we could go ahead and add all the views, as hinted at previously, add under view, and so on and so on. Once we did that, we could go to the views for the to-dos, remove each one of these decorators, and switch from declarative configuration to imperative configuration. And at that point, we could get rid of this line. In this section, we showed how a Pyramid web app can override views and static assets in an add-on. As shown in previous sections, Pyramid's view predicates provide powerful machinery for choosing which code to associate with a URL. Still, there might be times where you need something unique to your project as part of the predicates for view lookup. In this section, we look at two ways to do this. First, we'll use Pyramid's custom under predicates to select a different to-do view based on the ID of the to-do. Before getting started, we'll do a detour. We'd like to bring back the context object that we introduced in the route under factory section. That is, configure Pyramid to find the to-do and pass it into our views rather than making it the view's responsibility to locate the context object. Why is this important? Because we can then use this context in our custom view predicates. We're starting again from the code in the request under methods section. We'll add a route factory in to-do.views. So at the bottom, we're going to make a new function, to-do factory. It's going to be passed in the request. First thing we need to do is get the ID from the passed in request match dict. Then we're going to get a to-do from the sample to-dos based on that ID. If we couldn't find one, we're going to raise an HTTP not found. Otherwise, we're going to return that to-do. So in a nutshell, we're getting the ID from the route specification. In other words, from here, using that to get a to-do, and if we have one, returning it. Very similar to what we did previously. Next, we arrange for our views to accept and save the looked up context when it is passed into our views from the factory. So in the constructor for this, we're going to be handed the context. We're going to save it. This is no longer needed. The at current, so we're going to find all the places where we use current and instead return self.context. Finally, let's sort the to-dos in our list view to help us later associate our custom predicates. In our list view here, we're going to say to-dos equals sorted sample.values, and our key is going to be a lambda expression to-do. We saw this in the previous section, and now we're going to return the sorted to-dos. With these simplifications in our views, let's hook up the route factory in our add-ons under init under.py. On these three views, we need a factory argument, and it's going to be .views.todo under factory on all three of them. With this in place, the framework will locate the correct to-do and make it available in each of the view functions. Let's make sure that this works. Correct any errors that come up. All right, I have a list of to-dos. I have them sorted correctly, the first one here. If I go to visit one of them, I am actually using the route factory to get the context. On to our view predicates. Let's set things up so that viewing the second to-do, this one, uses a different view and template. So we want to have two views for handling the route name to-dos under view. One to handle all the cases and one to handle the specific case. I'm going to make a new one, and I'm going to call this lambda under view. And then I'm going to add in to lambda under view custom predicate, which is a pyramid predicate where you can provide a list of callables that will be run to test whether this view should match for that request. I'm going to write a lambda, an inline lambda function. And the pyramid is going to hand it the context in the request, just like a view callable, the under init above. And what we're going to say is if the context has an ID value that's equal to 2, then use this view instead of that view. We would also, in order to differentiate these, we want to call this one lambda view, the template. I'm going to go and copy this template to lambda view. And then I'm going to change its heading to say lambda view. Let's check that pserv is still running. Sure is. And let's go to our browser, see what happens on this. I'm going to click on to-dos again. I get the old view for that one, and I get the lambda view for this one. Very good. The custom under predicate did indeed work. Pyramid ran the function, this function, the lambda, when deciding which registered view to select. This is really useful in narrowing down highly custom cases. As a note, the function doesn't have to be a lambda. You could take all of this out and instead put it in something such as def lambda view context request return context.get id equals 2. Let's give that a try. I'm going to go down to the lambda view, and I'm going to change the name of this just so it doesn't make you think that it matters. And here I'm going to say lambda lookup, go over to here, and it still works. Custom predicates, though, are really for isolated cases. Wouldn't it be better if we could write our own predicate and register it? That indeed is the better way. Let's take a look at the docs. In this case, I can add to the configurator a new view predicate, in this case content under type, and point it at a callable. What would this callable look like? In this case, it's a class. It's going to be passed in some information. It needs to do some stuff to help Pyramid decide precedence. And then it's going to get called and be expected to return true or false. So in this case, whether this attribute equals the passed in value. We're going to make a new view predicate, new custom view predicate called context under ID. Let's make our view predicate class in the to-do subpackages under init under.py. So I'm going to go to the under init under.py. I'm going to make my class. I've gone ahead and typed in everything for the class. It has a constructor that's going to be passed in the value that is used in that predicate, and it's going to define the function and the other property which help Pyramid decide conflict resolution. And it's got its callable that will be passed in the context and request, quite similar to the way that this lambda function was passed in a context and a request. And finally, it's going to look at the context, and in our case, get the ID value off the context, hence the name context under ID, and see if that value is equal to the assigned value for this predicate. Because we use route factories, we have a context we can put it to use, and we see so here. We now need to register this view predicate in our include me for this add-on. So I will say config.add view predicate. I'm going to call this view predicate context under ID, and I'm going to point to the class that I just defined. Now, with this in place, we now have added to Pyramid a new view predicate called context under ID. We could put this to use with a third variation on this view we've been working on, the view. And I will copy this one, paste it. I'm going to call this predicate view. I'm going to make a new template called predicate view. I'm going to copy that to predicate view. I'm going to change the heading. But most importantly, for this new view, I'm going to get rid of custom predicates and use this one that we define, context under ID equals, call it 3, which means we need to come up and define a new to-do item, ID of 3, key of 3, and last one. Now, when we save this and let pserve restart, we'll go back to our site, click on to-dos, we see we have 3. The first one is using the view defined in the add-on. The second one is using the lambda view in the add-on using custom under predicates. Let's see if the last one did its trick. Sure did. Predicate view worked, which means that we were able to define a new view predicate for Pyramid, extend Pyramid with that predicate. So there we go for this add-on, a custom view predicate that can be reused across multiple views. We could even package it into a separate Python distribution and make it available to other projects. 2 extra credit items. First, a question. If we had both lambda and context under ID go for to-do ID of 2, which one would win? That is, if I put a 2 here, and this view was also trying to look at 2, which one's going to win, lambda view or predicate view? I'll give that a save. We'll go back to to-dos, go look at this one, predicate view won. Why is that? Because it is more specific than the lambda view. Next, do our views need to do equals self.context? So in this case, this one does to do equals self.context. This does to do self.context. Wouldn't it be nice if we didn't even have to do that? So for instance, on the view, I will stop passing into the template to do, and instead, if I could say context. Will this work? Let's take a look. It does indeed. The reason for that is Pyramid passes in context into templates at the default namespace. Just like request, just like view, it's a top-level variable available in templates. In this section, we register views specific to a certain custom situation, first with custom under predicates, and then with a full-fledged custom registered view predicate. Pyramid has been called a framework as it provides robust services for making custom policies for targeted needs, which can then be reused in interesting ways. We've seen some of this with subpackage includes, configuration settings, overrides, etc. Let's go a step further and show how our to-do subpackage can expose some of its inner workings to the MySite web app via Pyramid events. First, what are Pyramid events for? Let's take a look at the Pyramid docs. The first paragraph explains an event is broadcast by the framework at different times of the Pyramid lifecycle, but you can also create your own Pyramid events. For the Pyramid built-in events, you can listen to them imperatively, or you can add a decorator. And then finally, here's an example of an event subscriber in a subscribers.py file. And then finally, you can create your own events, for example, .created, and then you can register that event and notify it so that listeners can listen for it. We'll start again using the code from the Request Under Methods section as our beginning point. To familiarize ourselves with how events work, let's log a message when the application starts up to show how our add-on can participate in application bootstrapping. In to-do under init under.py, this file, here we'll add the event subscriber, meaning our to-do add-on code which runs when the event fires. Here I've typed in the event subscriber function. I've gone ahead and done the import which we will use when we add the subscriber, and it's going to be the function and then which event we want to listen to. Let's start pserve again and then watch this console to see if we did get the event created in the console, and indeed we did. This print statement ran here and showed us the event.app object. As a note, this was printed at startup time, not when a request was processed. That means application created, this event, is a good event to use when you want some work done after all the configuration has taken place. Here are some of the other built-in events in Pyramid. Under the Pyramid Events documentation page, we see application created, which we just used anytime a new request is starting, whenever a context is looked up, etc. We've now seen how to use a built-in Pyramid event. But what if we wanted our own custom events as part of the framework idea? For example, perhaps sites using our to-do Pyramid add-on would like to email administrators whenever a to-do is deleted. We could fork the to-do subpackage and add the code, but that means to-do isn't acting as a framework. Instead, the to-do add-on can anticipate that need and emit a custom event when the to-do delete view is run. By convention, Pyramid projects put events in a file named events.py, so let's start there. New file, events.py, and I'm going to make my event with a constructor, and it's going to be passed in the to-do and request. We're in charge of that. As the documentation notes, there is no special API for this custom event object. It's something that you'll create and explain how to consume. Next, we'll import this into to-do.views and add support in the delete view for emitting this custom event. So in my views, I'm going to, at the top, from events, import my event. And now I need to go to the delete view, and I want to change it so that I make the event And this is, as we described, you pass in the information you want in the event, the current to-do item, and the request. And then to trigger this event, pretty simple. I go to the pyramid registry, and it has a notify method that I call passing in this custom event that I just created. There we go. Our add-on now has support for firing custom events. Web apps that use our package can now run some code whenever an event is deleted. Let's see how that works. We'll create a new file, subscribers.py, again, the pyramid convention, in my site. So here, I'll create a new file, subscribers.py, and need to import the decorator. And now I need to import the event that I want to subscribe to and the decorator for that event, saying I want to listen to that event, and when it's run, here's the function. It will be passed the instance of the event. For now, we're just going to say, so in this case, we have a decorator that says subscribe this function to this event, save it. At the moment, it's not going to be picked up because our config scan only looks in views for the my site scanning. Let's just duplicate that. Let it restart. pserv is restarting, still printing out that previous error message. And then if I go to my site, go to a to-do and delete, go back to my console, I get that print message from my subscriber. It was listening to the custom event. The instance of the custom event, the to-do deleted, contained a to-do and request. Why did it contain that? Because we passed it in when we constructed that event and then called notify to broadcast that event. Some extra points to add. This registry.notify call can accept multiple arguments, each passed into the subscriber later. Also, like views and routes, subscribers, in this case our subscriber, can have predicates here, which narrow the selection of code that gets run on a particular event. We showed how view predicates can let one view run in one case and another view run in another case for the same URL. Same idea here. An event might go to one subscriber in one case and a different subscriber in a different case. In this section, we took a look at Pyramid's support for events and subscribers for built-in Pyramid events, as well as custom events defined in your add-on. Our add-on has used several of Pyramid's extensibility features so far. We've hooked into the request, the config, and even application startup. Let's show how to inject functionality before even getting into the WSGI application. Python's WSGI, Web Services Gateway Interface, has long supported pluggable code called Middleware, which runs on requests coming into and responses coming out of WSGI applications. Lots of Python middleware exists and can be easily used with Pyramid. However, these middleware packages don't get to use the value of the framework when doing their job. For this reason, Pyramid created the concept of a tween, Pyramid code that can run in between your WSGI app and the WSGI server. In this section, we're going to write a small tween which measures the execution time of your WSGI requests. We'll do the code in our MySite package, although it could be written as a separate Python package. Let's create a file, timeit.py. Here's the code for the tween. We import time from the standard Python library, and then we have a function that acts as a factory because it actually returns another function, the tween. That tween, timing under tween, is passed the current request. It records the start time, processes the request, records the ending time, and for now just prints the difference, end minus start, to the console. We need to register this tween in our application configuration, meaning under init under.py. I've added it here. Config has a method add under tween, which takes a string with a dotted path to the tween factory. Let's take a look at this in action by running pserv. When I reload a page and look at the console, I see the elapsed time of 3 requests one for the main HTML, one for the CSS, and one for an image. So far, so good. With this, though, the code will run in production as well as in development. We need a way to turn this off unless specifically turned on. Let's wrap the tween with a call to the configuration file to see if it should be used. I'm going to import from pyramid.settings the asBool function, which lets me convert the string for true or false into the actual Boolean. And then the tween I'm going to wrap with an if with the asBool of registry.settings.get do timeIt. That will be the configuration setting that we have, and we were passed in the registry, making it easy to get to the settings. Then all of this I will indent. I need to indent this as well. And then otherwise, if not enabled, we're going to return the handler. Restarting this, if I go and reload this page, I don't see anything because it's currently turned off. We will turn it on by putting in a configuration knob. We called it do under timeIt, and I'll say true. Restart, hit reload, and we see our timing console prints again. Of course, this tween is calculating the time on all requests, including those that are just to CSS and image files. We should change it to only log the requests we're interested in. For example, to narrow this to only log when the response is content type text/HTML, we can put another if inside the finally, and then indent those, restart, hit a reload, and we only get one printout for the one response that was HTML. Do this again just to prove, and then a second time you can see Pyramid is pretty fast. In this section, we covered Pyramid Tweens, a way to write packages which can perform specific request and response functions just outside of the WSGI application. This concludes O'Reilly's Python Web Development with Pyramid course. During the preceding sections, we started from the beginning of a Python web development project using Pyramid to quickly get a sample application going. After showing how to do modern Python development using packages in a project, we then went through most of the features of a modern Python web framework: routes and views, templates, forms, databases, and security. We then covered two topics: REST front-end development with AngularJS and extensibility using unique features in Pyramid. With these basics in place, there's plenty out there for you to do to continue your journey. First, the Pyramid core documentation is a fantastic resource. Broad, detailed, and always current. Also, the community maintains tutorials and cookbook resources for specific topics. You can also join the mailing list or the chat channel to ask questions in the Pyramid community or use Stack Overflow for a more structured experience. And finally, you can participate. Pyramid is a warm and welcoming open source project. Come hang out with us at the Python conference, or join the community to help answer questions, or even one day, become a contributor yourself. Again, thanks for